Good morning. So this is now, for me, I don't know, as well, 7th or 8th General Assembly I'm attending here. So clearly, just looking here, you can acknowledge the growth of the service, and as well the increased and ever-increasing maturity of the activities. And I think the event itself matured as well. So you see now, I think these days of splinter sessions, basically, to go into the specific topics, and as well the plenary, which is a bit more compressed. I think that's quite appropriate to not get lost somehow in the overwhelming complexity of this service. I would like to say maybe this year in the beginning saw as well a reorganization of ECMWF Copernicus activities. So Jean-Noël is there, so he retired as a Copernicus director. So I would say from my point of view or from outside, basically this ECMWF created a kind of EU key account, which is headed by Vincent Henry. I don't see him at the moment. And at the same time, the then vacant post of CAMS director was indeed filled with Laurence. So I'm very happy to see you here in this new capacity again after quite some years. And for the Copernicus Directorate, I think most of the team itself was integrated into a matrix type of organization. So I think we observed this carefully from the Commission, I have to say. And today I'm happy to say this is working quite well. So this whole transition from outside was at least absolutely non-disruptive, and it delivers as well a deeper integration between the Copernicus activities with the core tasks of the center and the know-how which is accumulated there. So if you look now back to the 10 years that have been just mentioned, so in 2014, for instance, member states were, the ECMWF member states were quite keen to implement a kind of wall between the core activities and the what's called third-party activities at the time. So, and now this demonstrates quite a change, and that the attitude is really very positive, and the synergies between Copernicus and the core activities of ECMWF are really acknowledged. So I think this reorganization so far proves to be successful, a success, and I hope you perceive that as well from the inside of the service. You can tell the same thing. Now, coming to a bit to the achievements. So clearly, this is a huge and complex activity, so it's literally impossible to mention all the achievements here. Nevertheless, to highlight some, I think the last months and last year seem to have been kind of the year of the aerosol or dust products. So there was a rollout of the aerosol service. There were several Saharan dust episodes, volcanoes, and so on and so forth. So this clearly is very interesting and a good development. I think there's even a specific session on that later today. So we have seen as well the first year of the Copernicus Health Hub, which is run by ECMWF. So this was successful in involving policy users to a much larger degree, so which have been maybe a bit far. It's very difficult for them to access a service like CAMS. So this is colleagues here from DG Sante, the HERA agency, WHO, or even EA. Another thing I want to highlight is the user uptake. So we have seen, again, large increase in the use of data sets. And there were some European countries which have significant increases in user numbers above 40% or so. Now this may be as well partially be due to the national collaboration program. I will come to that in a minute. Another thing, last thing I want to highlight here is the development between CAMS and WMO. So here how you have successful, or we all have been successful in positioning CAMS here as part of WMO's Global Greenhouse Gas Watch initiative. I think this is very, very promising. So now I would like to go into detail a bit onto three topics. So one is indeed the National Collaboration Program. Second is the CO2 monitoring and verification support capacity, and the aspect of compliance assurance. So for the national collaboration programs, I think we can say that is really a huge success story. And here in CAMS, you can credit yourself basically with the fact that you have invented this thing. Huh? So we use this as a tool to engage with the national user community, with the regulators, and by that increasing the uptake. Now specifically CAMS gets as well feedback into the European level of the service to reduce inconsistencies between services at the European level and maybe national activities that are nested inside. So our member states in the committee and elsewhere, they asked really very urgently for this NCP concept to be extended to the other services of Copernicus. And I think that's, again, that's a sign for that this is very successful. And this has become, or is going to become, basically one pillar of the user uptake specifically for the policy users. So how will we develop this maybe a bit further? So that's some points more for reflection. So clearly, there's interest by the member states for having in the NCP a transboundary element, so that you have activities which may extend beyond one member state and that can be linked with similar activities with the same objective in other member states. And maybe we will need to see as well a bit of kind of loose coordination at program level, and in particular visibility at the program level. So we have seen, so our user forum is going on in parallel today, so they will for sure would be interested to get a bit visibility on the overall thing of this topic. So the next thing I wanted to talk about here is indeed the CO2 MVS. So a very important input to the CO2 MVS are the CO2M satellites. So there is basically the satellites are at the CDR level, so critical design review, which means by now all of the design issues should be solved, the design should be validated, certain steps of the assembly and the qualification have already started. No? Nevertheless, there has been some issues being encountered with elements of the components of the instrument. So the launch of these satellites is likely to be late a bit into second half of 2026, I would say. Which is critical and unfortunate because it's interesting for us to use the satellite data for the global stocktake 2028. The good news here is that there is funding available for the third unit, so which is agreed in principle. So we're waiting basically now for a price offer from OHB, so how much this third unit would cost, and if these figures are then somehow in line with our pot of money we have put aside for that. So this is basically going to happen soon. So what do we conclude from these things in particular? So we think this underlines the necessity to be able to run and demonstrate this monitoring and verification support capacity initially in 2026 already based on existing data only. And so this means that similarly that the development and integration activity for this would need to be planned accordingly, that we can achieve that. Another element is clearly there's an increasing interest into methane. So the instrument of the satellite is capable to measure methane as well. So there is as well interest to have a bit the methane to be included somehow in this capacity as well. This possibly with using even complementary observations from SmallSat instruments, which would then basically zoom in into specific areas of interest. Now the last topic I wanted to talk a bit about is Copernicus for compliance. So basically compliance of member states, of industry, of entities, of stakeholders with EU legislation of various types. So in principle, the issue of compliance is built into the delegation decision and the agreements for all of the environmental services, including CAMS, obviously. But we have done, maybe at the moment, we have not developed that thought and this aspect very much in the past, or only I would say, ad hoc in a way. So what we will need to develop here in the midterm is as well the capacity for CAMS to answer basically on demand to requests linked to this type of activation, which includes then that we will have to have the capacity to handle this information in a kind of closed channel, because due to the nature of the task of compliance checks, you don't want to have this information in the public domain or on the CAMS website. Topics here can be clearly in the environmental area, so we can think about the Ambient Air Quality Directive. Here I think François will talk about that in a minute. But as well transport emissions such as aircraft emissions, so that's something we are getting asked repeatedly again and again. I know it's a difficult topic, but still. Similar for shipping emissions. There are areas in the channel or somewhere where shipping emissions are significant impact. Clearly as well, similar on terms of greenhouse gas emissions. So we are asked if and what we can contribute, for instance, to the emission trading scheme or to carbon removal certification, things like this. So all this is something to reflect upon a bit as well when sketching out then the next development steps and the evolution. So. I mentioned methane emission monitoring as well in this context here is still high on the agenda, including more and more new space observations as well. Lastly, priority at the program level, as I mentioned, is what's called a governmental service. So that's, I would say, an Earth observation service mostly focused on dual use applications. So clearly that's that's a reaction to the changed, I would say, overall political context over the last years, and the security situation in Europe has unfortunately changed considerably. Okay, so now to conclude, I think with this, with your track record you have, which extends even mostly more beyond 10 years, so you didn't start first thing in 2014, you have had a history of programs and projects before even, and the domain expertise which you collectively present, and in particular as well the professionalism you have demonstrated again and again in the past years, I think the CAMS is going to be definitely a defining part of all this future development I was sketching out. So I'm sorry to have overrun my time slot. Thank you very much for your attention.
Thank you so much, Hugo, for your nice presentation and also your strong support for so many years. Thank you so much. And are there some questions for Hugo? So for this session, just I say that for our colleagues online, we will take questions only from the floor in the room. So are there some questions, needs for clarifications? No? Well, it was perfectly clear. Thank you very much, Hugo. And now I would like to welcome François Vaquenit, who is the head of the Clean Air and Urban Policy Unit at DG Environment. So François, the floor is yours.
Thank you very much, Laurence. Good morning to all of you. It's really a pleasure to be here, and it's not my 8th CAMS General Assembly, but I feel part of the family because there's so much that has been done over the past years in terms of, well, enhanced cooperation that what Hugo also said a minute ago, that you've become a defining part of the priorities ahead of us, certainly in the clean air field, that applies fully. And what I will try to do is to illustrate this. I've got more slides that I can cover in the time that is available to me, but as the slides will be circulated to all of you after the meeting, I thought that it would be useful to leave them with you so that you can go deeper into some aspects that I will not have time to cover now. So obviously, and that is something that you're all familiar with, there are 3 components to clean air policy, and actually all 3 of them are relevant to our cooperation with CAMS. And I will cover 2 of them roughly today, but the third one, which is source legislation that you can see on the right-hand side at the bottom, is one that Hugo alluded to a few minutes ago with shipping, with transport emissions, and that is certainly an area that is very relevant because we're not going to succeed if we don't reduce emissions from the sources, and those sectors are sectors that CAMS can indeed improve action upon. When it comes to the other 2 clusters that I'll cover, the top one, air quality, well, it's relevant because we've recently almost completed the revision of our EU air quality rules. And in that context, we've got a few landmarks in terms of cooperation with CAMS, and I'll want to highlight that to you. And the second element that is directly within our remit is the reduction of emissions at national level through the so-called National Emission Reduction Commitments Directive, which we're in the process of reviewing now. And that opens also avenues for cooperation that I'll be happy to dwell on. So if we look at clean air policy at EU level, we can see very clearly that we've been successful at reducing the number of premature deaths over the past years, but obviously there's still a lot of work that remains to be done. And that is very much linked to the fact that unfortunately still today we witness too many health impacts in terms of morbidity and mortality, and the 300,000 premature deaths per year in itself is an illustration of the fact that we need to do a lot more still. But there are social, environmental, and economic impacts of a magnitude that really require additional action. And that's why, over the past mandate, Hugo alluded to the new parliament that will emerge from the elections. Well, the previous one led the Commission to launch the European Green Deal, and as part of the Green Deal, there was a commitment to revise our legislation on air quality, and that's what's been completed over the past mandate. But what I would like to illustrate here is that, well, I can skip all of this, but what I would like to illustrate is that, yes, this slide, as part of this framework, we've highlighted 4 clusters of focus, and those open very interesting segments of work, as part of which we can intensify cooperation with CAMS, and actually CAMS has been very useful also in the implementation of the current framework that we have, and that continues to apply until the new one is in place. And that holds certainly when it comes to monitoring and assessment, which is on the right-hand side at the top, where, as you can see, commitments were made to a number of novel elements, including in terms of improving air quality monitoring, increasing the use of modeling, obviously at the core of what CAMS can offer, and looking at monitoring pollutants of emerging concern. So with this, I just want to illustrate avenues of cooperation that the new framework has launched. And these are our new standards. They're very ambitious, and this is where we would like to be in 2030 with the proposal that we've made, which, by the way, has not been altered by the Council when it comes, or the Parliament, when it comes to the limit values that we've established. And the lighter blue it is, the better the situation is, and you can see that the improvements will be very consequent. But let me focus more here in terms of the recognition of the role of CAMS in the political agreement that the Council and the Parliament established. I've mentioned elements of cooperation that are very much linked to what you can provide. Well, in the text itself, in the legislation itself, and who also referred to that earlier, we've now got a full anchor for CAMS to actually be a contributor to the work ahead. I think this is quite a pioneering development, and one that will be extremely useful in building the implementation framework of the directive. And you can see that this refers specifically to the evaluation and quality assessments report, to obviously monitoring and modeling requirements under the new framework. So the CAMS contribution is recognized in the legislative framework that is ahead of us. But let me go a bit deeper into what CAMS will actually be of use when it comes to implementing our framework. And so what I've highlighted on this slide is some of the key elements where we see a CAMS input as being directly relevant. First one, on quantifying contributions of natural sources to air pollution. Some of our member states already use CAMS products to identify contributions of natural sources to air pollutant concentrations as regard exceedances in the context of the AQD. But not all member states do it, and we can take that further. We can scale this up, and that is one of the elements ahead. We can also look into the use of CAMS information on the quantification of contributions to background air pollution. This will require partnering with some of the established partners in our implementation framework, Fair Mode being one of them, and many of you will be familiar with it, and with the other networks that are relevant here. I'm thinking of Actris and EMEP within the context of the Air Convention to strengthen the validation procedures. Moving on to transboundary contributions to air pollution. This is a sensitive issue. This is an issue on which member states have expectations that we go into more analysis, and this is something that CAMS can help us with. Use of CAMS also in terms of forecasting information, including as input to the air quality index that the European Environment Agency has developed over the years, and which is now a bit of a new landmark in terms of documenting in real time the situation in the air quality exposure that we face at our city level. Use of CAMS forecasting information, including as input to the air quality index, is what I've just covered, but we've also obviously looked at other aspects linked to downscaling activities. So health risk assessments in the Copernicus Health Hub, or input to the EA and the Joint Research Center on environmental health services, because it's not enough to give information about the air quality situation in real time. We need to translate that into what this means on one's health, and therefore how one can manage and mitigate exposure risks. Lastly, CAMS information to support air quality plans. Air quality plans are a key tool for the implementation of the directive, and there is more that can be done there, including when it comes to source allocation services and scenario development into projecting future compliance. So this will particularly be of use on one of the aspects that I've mentioned earlier, which is modeling. So I'm not going to go into the detail of what I've listed here, but what I wanted to give you is a sense of how essential modeling is now recognized further in the revised directive. It was already present in the current one, but it's been taken to another stage. And that means that we now have further opportunities for cooperation on that segment of work. And I'll skip this and I'll move to the National Emission Reduction Commitments Directive, which is another cluster of work which offers cooperation possibilities. So the directive is not in the same sort of policy cycle moment, in the sense that while we're finishing the revision of the Ambient Air Quality Directive, we've initiated the review, so the evaluation of the National Emission Reduction Commitments Directive. And that is a process that will be finalized in 2025, at the end of the period. And that offers the possibility for all stakeholders to come into the discussion. So there's a call of evidence that is open. We've got possibilities for stakeholders such as yourselves and all the authorities that you represent and work on behalf of to contribute to possibilities in terms of future cooperation. We have ways in which we're already cooperating with CAMS on the implementation of the NEC directive, and there are actually also cooperation streams that go into other Copernicus family members, C3S being one of them, when it comes to flexibilities used within the directive's framework. So there are options that we can consider also as part of the evaluation. You've seen the 5 pollutants that we cover. Methane was mentioned earlier by Hugo as one key pollutant in terms of future focus of CAMS work. Just wanted to highlight here that the Commission, when proposing the revision of the NEC back in 2016, when we had a new NEC adopted by the Council and the Parliament, wanted methane to be one of the pollutants covered. As you could see from the list that I very quickly showed you earlier, we only have 5 pollutants right now, and methane is not one of them. Methane is not one of them because the co-legislator so decided. But the Commission's view, and we documented that at the time of adoption of the NEC, was that methane should have been covered. And methane, from our perspective, is a pollutant that remains of key importance. Our view has not evolved in that sense. We had issued a declaration to the political agreement by the Council and the Parliament to signify so. So this is going to be part of the assessment of the directive that we're currently going through. And it's very clear that methane, from an air emissions viewpoint, but also from a climate viewpoint, obviously, and connecting to an air quality perspective, is a pollutant that remains, well, certainly at the core of some of the preoccupations that we haven't yet addressed. So we'll need to look at whether that gap is a gap that should remain, or whether that gap is a gap that should be addressed. I cannot conjecture about that, but the evidence that we can get through CAMS on methane is obviously going to be a very useful element for those reflections. So what I wanted to illustrate here is also that you can help shape new legislation if there is a decision to revise, which, by the way, is not a given, because an evaluation can lead to status quo as well. But you can feed into those discussions and contribute to informing the debate and the policymakers about the processes ahead. And what I've put here is the timeline for the review, and well, you can see that it will leave ample time for consultations and for evidence to be put on the table. So here's an invitation from me for you to do do as much as you can to contribute to this debate and to enrich our reflections on the future of the NEC directive based on the experience that we can draw from the implementation of the directive since 2016, because the exercise is a retrospective one. It's not a forward-looking one, so we'll need to look at whether we've been successful, and for that we assess 5 criteria: effectiveness, efficiency, relevance, EU added value, and coherence, that is policy coherence across air, climate, and all the sectors that are relevant to our work, from transport to energy to industry, but also those that are fed by the efforts that we deliver upon. I'm thinking here about health, agriculture, etc. So CAMS support on the implementation of the NEC, being quite concrete once more. So I've mentioned C3S. There's the use of C3S to account for exceptional meteorological conditions within one specific year, which is linked to one of the flexibility mechanisms under the NEC reporting. So we're looking at the implementation of the directive today and the use of CAMS for that purpose. But we can also look at new possibilities in terms of CAMS mobilization, one of them being the use of CAMS emissions and concentrations for national inventory and other reporting under the directive, possibilities for gap filling on reported LCP, large combustion plants, industrial data, use of DPRTR, diffuse emissions, forecast of emissions. So this is something that is another use that we could certainly go into additional mobilization. And lastly, the possible use of inverse modeling to flag possible inconsistencies and gaps in the reported areas, because we want to be as accurate as possible in order to be as effective as possible in addressing the challenges that we face. So what I've tried to give you, both on air quality and on the NEC directive, are illustrations of, current uses, potential intensification of those uses, and further uses. And so this is a menu that you've already tasted when it comes to the uses that you've provided already, but this is a menu you can actually expand if you so wish. So my invitation is obviously for that to be done. And with this, I'll finish with what's key to success from our perspective: synergies and cooperation, quite obviously, in the sense that we've built in the clean air community a very strong cooperation framework with a number of actors, and they're very valuable networks that deal with our priorities and support implementation. And Hugo mentioned earlier, very aptly, the need to emphasize more uses of CAMS in the context of implementation. So each of those support groups that I've listed here have specific allocations and functions. Aquila, Fair Mode, the European Agency and its IONET network, the Air Convention in Geneva, and EMEP, and of course, last but not least, and many of you are linked to those, the national and local level competent authorities that deliver extraordinary work to support our work. So CAMS is one member of that implementation framework and family now. Remember what I've said earlier about the directive air quality that now fully even recognizes CAMS as being a contributor to our work. CAMS has much to offer, to feed, or rather to continue to feed, and to feed even more intensively and extensively into the processes ahead. So this was, of course, brief, much too brief to go into the details of what that can provide, but I hope that gives you an idea of the expectations that we have, the gratitude that we want to express to you about what you've provided already that has been very precious to the implementation process and to the shaping of future clean air policy. And obviously, we want to continue the journey with you, and we are confident that with the expertise that you bring, with the networks that you bring, with the evidence that you can build, we will be stronger in addressing the clean air challenges on the way ahead. And I'll finish with the public health emergency that it still is. And so you're part of that journey so that we address it and we deliver what our citizens certainly deserve, which is cleaner air quality for them to breathe. Thank you very much.
Thank you very much, François, for this nice presentation. So we know what we have to do now. Any questions for François? Yes, please.
So thank you for your presentation. You briefly mentioned You briefly mentioned health, agriculture as impact, but you didn't go very much in detail about those important topics. And I'm kind of wondering, at the Commission level, how deep is the connection with the directorates that deal with these questions, for example, health, or for example, agriculture? We always say it's important, but does it really work inside the Commission? Does this connection really work? Are the people here, for example?
Yes. Well, I was brief because of the time constraint, not because I did not want to dwell on cooperation with those services. You've mentioned health and agriculture. We work very closely with those services. We work very closely and very constructively. Obviously, air quality is a health stake of a magnitude that requires the public health community to be fully on board. So this is something that we work on intensively with our colleagues in DG Santé. So that's the answer to your first question. On the agricultural link, we work very closely with our colleagues in DG Agriculture. We've organized over the past years, in the context of the implementation of our legislation, many events in common, actually, in order to try and stimulate action from the various stakeholders that we can influence through the policies that we're in charge of. And it's very clear that when it comes to ammonia emissions under the NEC directive, for instance, we must work with agriculture. This is the sector that is the key to addressing this problem. But at the same time, what we also work on is the understanding, if you like, from all actors in the sector that agriculture is not just a source of air pollution. It is, just like some other sectors are, but it is also a sector that suffers from air pollution if we think about the impacts of ozone pollution on crop yield. So we do also have a dialogue, if you like, that goes into building cooperation that goes into the interest of both, because what we've been convinced of is that we'll only succeed if we can also find a pathway that makes sense from the perspective not just of the players that I represent through the environment segment, but the sectors that also contribute to solving the problems that we're faced with. So we work very closely with DG Agriculture and with all the sectors, by the way, because they're also involved. So all the representatives of the farming sector contribute to our consultations, contribute to our discussions, and we certainly want them to engage as actively as possible, because there's no way you can actually address a problem when it comes to ammonia emissions, as I was referring to earlier, if the sector is not on board.
Thank you. Other questions? No. No, it was clear. Thank you. Thank you very much, François. And I would like now to welcome Brendan Devlin from DG Ener, who is advisor to the Director General of Energy for Energy. So, Brendan, please, floor is yours.
Well, thank you very much, and it's a great pleasure to be here, to be the third Commission speaker. It's my job to give you an uplifting story before the coffee break, I think, is next. I'm here to tell you the good story that we have on methane, specifically methane from oil, gas, and coal emissions, and how the European Commission has used the CAMS service to put in place a global agreement on methane emissions reduction and specific legislation inside the European Union to reduce methane emissions. And it would be not an overstatement to say that without CAMS, we would not have been able to have achieved this. Cast your eyes back 10 years ago in 2014, we were in the energy department looking at the transition in fossil fuels away from coal to other fuels. And the question at that time was, should we use fossil gas, natural gas, as a transition fuel for the future? In a determined period of time, should we use that gas in preference to coal to create electricity specifically? We knew at that time that if there was an emissions rate of more than 3% in the supply chain for fossil gas to the burner tip, then it is better in climate terms to use coal, not in other terms, for example, PMs, particulate matter, and human health reasons, but just purely in climate terms. If there is an emission rate of more than 3% in the natural gas, the fossil gas supply chain, then it is better to use coal over a 20-year time period. And so the question that was raised was, can we assure that if we switch over to fossil gas, can we assure that the emissions rate is less than 3%? Now, we knew that some suppliers had very low emission rates. Norway particularly has an extremely low emission rate. But when we went to other countries, the United States, Russia, when we were still speaking to them, Algeria, other suppliers around the world, we said to them, are you emitting methane in the supply of hydrocarbons to the European Union? And what can you do to prove it? And all of those suppliers said, no, it's not us. I think it's absolutely certain that not a single supplier said that they had an emission rate which was above negligible. And certainly at the government level, that was the case. The United States, Russia, Algeria, and all the other governments that we consulted all told us that emissions from anthropogenic methane in the supply chains for hydrocarbons were negligible in their jurisdictions. And yet we knew here from this slide that globally methane emissions were increasing and the amount of methane in the atmosphere was increasing very high. You'll see from this graph that there was about a plateau in the years 2000 to 2005 when methane emissions seems to have dropped off. Around about 2005, 2006, we see an increase. That, just by chance, is the start of the fracking boom in the United States. And there we see, by coincidence, an increase in methane emissions and an increase in new supply systems, particularly from the United States. So, in particular, we were interested to know whether the United States was emitting more methane than was being recorded in their greenhouse gas inventories. They said no. But CAMS gave us this. And this is a picture of all of the Copernicus recorded large emissions of methane in 2019. All of those spots record an emission of more than 10 tons per hour. And globally, all of those spots amount to 2.7 of global methane emissions, which is, I think, my mathematics not being as good as a French person's, about 10% of global emissions from anthropogenic sources. So we could say to the United States, actually, we think there is a problem. We could say it to the Russians as well, to the Algerians, and to all of our partners, saying there is a specific problem in the hydrocarbon supply chain. And not only do we have this data, which shows us the large emissions, we could map these emissions to infrastructure. This is the Russian compressor and gas pipeline system. And as you can see, it could be a coincidence, but there seems to be some sort of identity between methane emissions and the supply chain from from Russia. We have similar maps for the United States. We have similar maps for Algeria, Venezuela, etc., etc. So a decision was taken in 2020 to do something about this. First of all, the European Union would implement regulations within the European Union, which would deal with the emissions that come from our own supply chain. But as you can see, there are relatively, well, in fact, there are none. We only have emissions from waste dumps and agricultural facilities in the European Union at this level. But we would certainly take on the burden of putting in place regulations that would cut down methane emissions in the European Union, and we would also seek from our suppliers to implement similar regulations. That legislative package was agreed very recently within the European Union and has become law in the past month, I think. And this is going to be extended out, our legislation is going to be extended out to our partner countries over the next 5 years. Equally, we said to the United States, we have to do something about this, because in the European Union, we will be taking far less oil and gas in the future. We will start a decline in gas use probably this year or next, in oil use probably in 2027, 2028. And in that period, we will be able to choose between the best suppliers and the worst suppliers. And in particular, we said to the United States, look, if you want to stay in the supply mix beyond 2030, you, the United States, and other suppliers will have to perform much better. And with the United States, we proposed, and then we agreed a global methane pledge to reduce anthropogenic methane emissions by 30% by 2030. And that gave a domestic spur to the United States to introduce methane emissions regulations, which have recently been adopted at the federal level in the United States. We know that methane emissions and CO2 emissions in supply chains amount to about 15% of global greenhouse gas emissions, all told. That 15%, if we could reduce it to the level of Norway, would be equivalent to taking out the United States from global greenhouse gas emissions. So it is a prize worth having, and it is something that we want the European Union, but particularly CAMS and Copernicus and this community here, to take credit for, because without your work, we would not have been able to have persuaded the United States and the other 160 or so countries around the world that have signed on to the global methane pledge that this is something that we can achieve and we can do. So CAMS has been absolutely key. For the future, we need to think about how we will use data from satellites to smooth the fossil fuel phase-out that we are anticipating in the future. It's now a day-to-day occurrence that we see news items like this, satellites spotting methane emissions, and now through the United Nations, the rapid alert system that we have put in place with the United Nations, talking to Argentina, talking to the operator, and getting these emissions immediately closed off. We would like to see from DG Energy an expansion of CAMS capacities to give us near real-time ability to look at methane emissions in the supply chain. If we could do that, we could use that data to guide the fossil fuel phase-out that we anticipate from 2026, 2027. We could facilitate greater access for the good guys, the people who do maintenance, the people who keep their systems clean, such as Norway. There are others like Qatar who have very low emissions, and to give them greater incentives into our market. And we could close out the market from those who have very high emissions and contribute to that 15% of global greenhouse gas emissions that are in the supply chain. CAMS has been a success in the past, dealing with methane and giving us the basis for our legislation and our international agreements in methane. I am hoping that CAMS will play a role in the future in the transition away from fossil fuels, and in particular give us access to data that will give us a global view of who is digging what out of the ground and putting it into the atmosphere. Thank you very much.
Thank you very much, Brendan. It was a very interesting story and a big challenge that we have to deal with. Any questions for Brendan? No?
You could just turn to each other, shake hands and say well done if you want. Please.
Thank you so much, Brendan. Thank you. So now, yes, this is the end of this first session. Unfortunately, we were supposed to have a talk from DG Climate, but the person had a problem. So now this is the end of this first session. So we could invite you for a coffee break. I don't know, we are supposed to come back at 11. That's okay. Okay, so let's have a coffee break. Many thanks to all of you. Many thanks to the speakers. And let's be back at 11.
All right. I hope everyone has found a seat again and had some good conversations over coffee. Good morning again. My name is Richard Engelen. I'm Deputy Director of CAMS, but I think most of you know me already. After this exciting morning session with the really nice feedback from the Commission, the different DGs, we know what we need to do in the coming years. And this session we will actually have some presentations from the other agencies we work with, which are really important to do what we need to do within CAMS. We can't do this by ourselves, and especially on the observation side, where we have EUMETSAT, ESA, and the EEA tell you a little bit more about their work. This is really critical for what we do within CAMS. I'm not going to say much more. I'm going to leave the floor to the speakers, and I'm very pleased to introduce, as the first speaker, Laurence, to say a little bit more about CAMS as a service.
Thank you very much, Richard. And just waiting for the slides. I have to do something, perhaps? No? So I am supposed, I will start not to lose too much time. So I will give you a brief overview of the state of play of CAMS today, with an overview of the various aspects, services that we develop within CAMS, and some key results that we have obtained during the previous year, since the last assembly. But now we need my slides. Okay. So, just waiting for the slides, I will try to just to remind you that CAMS is one of the 6 Copernicus services, and CAMS is really focused on atmospheric composition, knowing atmospheric monitoring, forecasting atmospheric composition, understanding its drivers as well, and understanding the impact of atmospheric composition on health, environment, when we talk about air quality, on climate forcing, on solar radiation. Yes, okay, on solar radiation everywhere in the world and in Europe. And just to remind you, you know very well this pitch, just to remind you that CAMS is an integrated system which gathers information from in-situ networks, regulatory networks, but also research networks from Earth observation. This information, this data, is used in models that are developed by ECMWF and by our contractors at the global scale with a 40 kilometers resolution, but also at the regional scale, the European scale, with a 10 kilometers resolution. And there are differences between the global and the regional scale. For the regional scale, we have a multimodal ensemble approach, which is based on 11 models running everywhere in Europe, run by the best teams in Europe. That allows us to build up this ensemble, which is a good estimation of what happens. And with that, we are able to provide some assessment, some forecast analysis for the D-Day, reanalysis, historical data sets that can be used by numerous users for various applications. It remembers me something. Yes. So François highlighted the role of CAMS, that CAMS will have, especially in the implementation of the revised Ambient Air Quality Directive, which has been agreed by the European Parliament in April. This is an example of the kind of policy application that CAMS had to commit with, which means that we have some obligations. And this is not only for the implementation of the air quality, but for all the applications that we develop. We need to develop cutting-edge science. We need to ensure that our products are relevant, are robust, are reliable. We need to ensure transparency about the capacities of those products, trustworthy, access to data, and user support. And this is what we try to develop. I will go a bit more into details of the products, but keep that in mind, because this is really the way we think about our products. So just to review some activities. If we talk about the air quality, the implementation of the air quality directive and air quality policies, I would like to inform you that we are about, I really have a problem, I don't know what to do with that. Okay, just to say that, perhaps it will come a bit later, just to say that we are about to publish the 2023 Interim Air Quality Report. This report is published every year. It is based on reanalysis, based themselves on interim air quality data. You will have a longer presentation about this tomorrow in the policy service presentation. But just to say that with this kind of report, we hope to offer to the users, to the policy users and the national experts, some material that could help them to deal with their duty work, their duty reporting work regarding the implementation of the directive, to report exceedances of limit values, and to report information about air pollution patterns and air pollution, background air pollution. Yes, so it's here. In the report, you will find, comparison of the 2023 situation with what happened in the previous year. We started to produce those reports in 2013, so you will have some comparison. Information about some indicators, metrics, air quality metrics, and also in-depth analysis of episodes. But certainly, we'll have more information tomorrow during Augustin's talk. Also, I would like to highlight, to draw your attention on the policy tools, because we talk about policy and air quality policy, just to remind you that there are those web pages, policy web pages focused on policy tools, and they have been updated this year. For instance, there is this air control toolbox, which is an online tool. You can play with it, reducing emissions from various sectors, traffic, industry, residential, agriculture, and looking at the impact of those reductions on air pollutant concentrations. And now shipping has been added to this tool. And Hugo said that this is very important. It will be very important to take into account shipping in future legislation. So shipping is now in the tool. There are also other informations, for instance, this picture, which is a bit complicated, but some of you understand what it means, the chemical regimes. Once again, playing with a tool and looking at the impact of reducing this sector on ozone and PM concentration. And we know that the response may be non-linear. In fact, this is not because you reduce by 20% the emissions, that the impact will be reduced by 20%. And sometimes the impact is an increase. So it's very important to have that in mind, and we propose this kind of tools. As an information about the PM chemical composition and PM sources, also contribution to the air pollution event. And we have put online the yearly synthesis that is published in the interim and validated assessment report. Now you can access this information online. And also the air quality plots forecast analysis have been updated, so there are now a new interface with new products that allow to have an information about, thanks to CAMS series, about uncertainties of what we are doing. For instance, here you have a time series, you have in black the average, median average, so the ensemble, but you also have an information about the range of variability of the various model responses, which is actually an information about the uncertainty. Okay, it needs some tough work to interpret that, but once again, it's important to be very transparent. And a new product that we have published at the beginning of this year is this new forecast products at the location of the monitoring station. This is an optimized product. In fact, thanks to artificial intelligence algorithms, this is very fashionable. At the location of the station, we improve the reliability of the forecast. We correct, in fact, the forecast thanks to additional variables, the concentrations monitored at stations, or ancillary variables, and thanks to that, we can improve significantly the quality of our forecast. So that's for air pollution. Also would like to highlight all the work that is done, not only with the regional model, but also with the global model, to be able to monitor online and to provide an information online as quick as possible about natural dust events that could impact very large-scale areas. So this is a dust event that occurs currently. It was yesterday. Those were the forecast for yesterday's, and with this episode impacted Greece and east part of Europe. And this is also a kind of activity that we developed with Fairmode. François mentioned the collaboration with Fairmode, and I wanted to highlight this collaboration that we had. You will hear about that this afternoon with Fairmode to be able to define guidances on how to use CAMS product to be able to detect and to predict the impact of those natural events on PM concentrations and perhaps on the exceedances. Because what the directive says is that in case of exceedances, PM exceedances due to natural event, you can subtract this contribution. So this is very important for the member states to know, and we try to help in that sense. In information, we have opened this new service at the beginning of the year, the Aerosol Alert Service, which allows you to have a look in near real time at what happens in the world regarding aerosol events and PM exceedances. And also this is, so we have already more than 100 users registered, and this is a customized service. You can register, and you can decide to receive some alerts for some areas or for some times, and you can also provide some alerts. So this is also the kind of user support service that we aim at developing in the past. in the future, sorry. Important development in the global system in 2023. Last year in June, the chemistry scheme, the stratospheric chemistry scheme has been updated thanks to implementing the BASCO model from BIRA with additional species, which helped in improving the quality of our forecast, especially to monitor the ozone hole, but also some development have been made to improve the dust aerosol and organic aerosol modeling, and also in October, operational use of Sentinel-5P NO2 data was in place in the global system. A few words about the emission inventories activity. So you know that we have this activity for quite a long time based on the production of global and regional emission inventories for greenhouse gases and air pollutants, which are based on existing inventory and reporting emissions. So this is an ongoing process with an update every year that provides some information, relevant information for our modeling systems, of course. But we have also developed this, what you see on the bottom, this new approach based on near real-time activities information. This is a cooperation with the Carbon Monitor project, and we have participated to the implementation of this activity, especially at the EU level. And you can see this kind of information, so the monitoring the CO2 emission sector by sector and country by country, and also the evolution from a year to another on the website. Inversion data, so you know that we have a huge activity on the production of fluxes, inversion fluxes for CO2, for methane as well, and N2O, and this is an ongoing work, and it helps in developing some capacities for future work on observation-based emission. This is the next step. What we really are focused on for the near future, to be able to develop those observation-based emission inventory that are based on Earth observation, a priori information from emission inventories, modeling framework, inverse modeling framework, to be able to assess, to verify, to monitor the emission and what is what is reported, and the difference between what is reported and what is actually observed. And it gives, of course, a very important information, policy relevant information. So this is something we are working on closely with DG DEFIS, with DG Climate, with DG NR. That will be really an important feature, and sure that next year at the same assembly you will have more information about our work on that for CO2 and methane. And this work is driven by satellite information that we will receive, especially the future mission. I mean Sentinel-4, Sentinel-5, CO2M. Hugo mentioned those projects, upcoming projects that will be really important for future development. I do not detail you. We have once again more information in the presentation later and tomorrow. Just one slide to say that, of course, to develop that, remember that I said that all that we do is science, cutting-edge science level. We need to develop research projects. We need, with our partners, to develop research projects. So we have a battery of research projects that help us to provide, to prepare the future, to pave the path for the future. So here are few projects that are finished, that are ongoing. Perhaps you have seen on our ECMWF websites very nice movies coming from the COCO2 project, with those nice movies of concentration of CO2, methane for 1 year, for the year 2021. Just to say that there are many projects ongoing. We will take, of course, take stock of the outputs and the results of those projects to develop the future operational things. You will have this afternoon a presentation and more information about the National Collaboration Program. This is something that is very important for us to get in touch with our users and with the national experts in the countries. Ugo mentioned this, and also the thematic hubs. As Ugo said, we are responsible for, at ECMWF, for 2 thematic hubs, the energy hubs and the health hub, and you will know more. The idea is really to be able to provide one community, health, energy, Arctic, coastal, with gathered information from all the services to be able to develop some products, some tailored products. Few words, we don't do that a lot at ECMWF. CAMS is a family. Just to remind you that there are 140 entities involved, are contractor or subcontractor from 24 countries. A lot of contracts signed, very ambitious procurement plans that we need to implement this year and next year. Of course, this is a world community which is built. And one word about access to data. It was one of the topics that I wanted to, that I highlighted at the beginning. All data that we provide, that we produce, is available, accessible on the Atmosphere data store. Perhaps you are aware of the fact that we are upgrading our system to have a joint approach between the Atmosphere data store and the Climate data store in the ECMWF framework. So this is to increase the efficiency for the users. It should be quite transparent. It will not change your life, but for us, it should be perhaps better for the maintenance and more efficient. So a new management system will coming soon. There will be a beta version released at the end of June, beginning of July, and the new system should be in place. This is our objective at the end of July. So things will change. You will be invited at the end of June to test the beta version, so please send your feedback, and also be not too hard with us, because there will be a transition period. But it's very important to get your feedback. So this is really for the coming weeks and months. User statistic, you will have the slide, so I will not go into details. Just to say that we increase year by year the number of users with some products that are more popular than others. That's interesting to know. And also, I would just like to mention that you will have also a presentation about that this afternoon. That we have. This is a part of our commitment of user services. Now the Copernicus services are part of the ECMWF user forum, which help us to be perhaps more reactive and to make the Copernicus services being a part of the ECMWF forum helps to have a more robust and reactive approach, I would say. And now there is Xiaobo will present that there is a user support journey, so you can find a solution to your problem at various steps. We hope that it will work well. And just a word also about the training activity. You will have the slide just to remind you that we also hope to support our users with this. And with that, I would like to thank you with your attention. With Richard, we are here to answer all your questions, if you have some today or in the future. Many thanks also to all the CAMS teams for all the nice work that is provided. Thank you very much.
Thank you very much, Laurence. We have time for a couple of questions, if you have any. No, all very clear. And again, as Laurence said, there will be more information later today and tomorrow about all the aspects of the services, so lots more to come, but thanks for the overview already. Next presentation is from Federico Fierli from EUMETSAT. We all know EUMETSAT as a satellite data provider, but we actually do a lot more with EUMETSAT as well. And Laurence briefly mentioned the training, for instance, where we do work with Federico quite a bit, and ESA colleagues as well, actually, to provide comprehensive training. But the floor is yours now to talk a little bit more about EUMETSAT.
So basically, I will provide you which is the present and the future for Copernicus and contributing missions, how we support CAMS in terms of providing data sets that are key for the process of assimilation. Do you hear me right? Okay. And also in terms of providing forecast, but also I will give you some elements on which are the relation with the user component, the training, and which tools we do implement within the framework of Copernicus in cooperation with CAMS. So basically the point is that satellite compose what we call a unique data value chain. I give you the example on how it works. So we start basically here with the forecast. These are forecasts coming from ACNWF. This is a risk, a wildfire risk. So we are talking about wildfire. The season in Europe is at the doors. With the satellite, we can monitor what happens. This is the example of the intense wildfires in 2021 in Greece. And then through the assimilation, we go back into the models, providing estimates of emissions of the occurrence of wildfires that are crucial for supporting the emission estimates, generated added value products, and also adding value to the information that you have from satellites that have gaps, holes, and also the need to go in continuity. The message is that there are a lot of satellite datasets to use. You will hear also from the European Space Agency that is partner in this effort at the European level, but there is a lot to come, and this goes into the Sentinel, so into the Copernicus programs. We are talking about Sentinel 4, 5, CO2M, but also with the so-called mandatory missions that are on board the Meteosat third generation, that is the geostationary program, and the METOP second generation, that is the polar program. So basically there is a unique blending and unique ensemble of the potential to monitor and to integrate in services like CAMS. I start with the existing. So this is the example from Sentinel-3. These are data sets that provide the monitoring of the aerosol. This is aerosol optical depth, and these are fires. Basically, these data sets are currently getting integrated into the CAMS systems, are monitored. So we work together on this, and are also contributing to the emergency management system, but also to WMO and to activities at the international level. Basically, the point is that this data, this is an example on the Canada wildfire in 2023, can help both in monitoring what's happening in real time. This is, for instance, smoke and fire pixels, but also to support and to collaborate with CAMS in terms of the evaluation, for instance, of the wildfire life cycle. And this is an example on how during the fire season in Canada the things happen. So basically, there was a very early season with a very intense amount of fires. The synergy on wildfire monitoring also make use of different data sets. I don't know if it's working. No, it's not working. No problem. Can I go back? Okay. This was supposed to be animated, but is not a problem. So basically, using the fire information together with the carbon monoxide, this comes from YASI, that is a collaborating mission on METOP. This is also GOM2, and this is again GOM2. So these are two collaborating missions on METOP, but this will be expanded with the new missions. You can have an integrated view from the observational point of the evolution of the long-range transport. And this is crucial, for instance, for assimilation and also validation of the CAMS approach that provide elements in terms of emissions. And also there is the possibility with the long-term time series that have been mentioned, so the fact that you have a climate data record, to evaluate whether a season like the one in 2023 is anomalous with the long-term data set. And we observe that in fact there was a very intense anomaly, about twice the concentration in carbon monoxide in 2023 over the Canadian area with respect to the past. Dust has been mentioned, that this is another element and another example. This comes from the PMAP, that is a synergistic aerosol dataset that is currently partly assimilated and partly monitored by CAMS, and that this is an example of the long-term occurrence of dust observations over the world. And the PMAP comes with both a concept of near real time that is a supporting forecast, but also in terms of climate data record is also provided to the C3S in order to have long-term monitoring of the dust evolution. And talking about the near real time, this is also an example on how the synergy works. These are, for instance, visible observation from Severi together with the CAMS forecast and then with the potential impact in terms of exceedances of particulate matter. Just to mention which is the endeavor of having coherent satellite dataset, basically this is needed to make reprocessing in order to ensure that the satellite drift, the changes in instrument are taken into account, and this is particularly important, for instance, when it is reassimilated inside in the reanalysis, because there is really the big need to have a coherent evolution. Talking about the continuity, I should mention the SAF, that is the Satellite Application Facility Network, that is supported by EUMETSAT, is a EUMETSAT program that is implemented by national services, by groups of experts, institutions around Europe, and the one that are relevant are the atmospheric composition SAF and the climate monitoring SAF. I mentioned also the OSI SAF, the ocean SAF, because it's a very big contributor to CAMS. So these are really elements that EUMETSAT uses to contribute to the Copernicus effort. AC SAF provides near real-time offline and data records, to cover the different needs and the different aspects, and CAMS is the primary user for the SAF, for the AC SAF products. In particular, these are the dataset, the instruments with the different species that are used now in the global real-time forecast system assimilation, and also in terms of monitoring. And there is also a plan of assimilation of YASI datasets. Here there is the ammonia that is missing, and I will show you in a moment one example. As I said, one big effort is also to have a coherent data series. And that this is an effort that AC SAF made in the recent year to provide a climate data record at level 3. So basically, these are gridded, quite easy to use for the users. And that this is an example, for instance, of nitrogen dioxide. How it is reprocessed. So the yellow line means that this is a data set that is now fit, for instance, to be integrated or compared with the reanalysis, with respect to the offline that is basically the near real time that can suffer of changes, of degradation, of biases, and so on. So I don't enter much in details. There is Seppo Hassinen in the room, at the end of the room, and he is the coordinator of the AC SAF activity at FMI. And basically, this is a sketch, an example of the level 3 data sets that are produced by AC SAF. And this is, a strong support in terms of air quality assessment, air quality evaluation. It's really integrated into the model plus observation. I have mentioned ammonia. Ammonia is a product that is measured by YASI. And will be measured by the YASI next generation. Ammonia is a very difficult product to observe, and there is a very strong effort also in terms of identifying, accumulating data sets over years to identifying hotspots and emissive points that are missing. Is a concept quite similar to the one of methane. So we are really, with the observation, we're really discovering where things happen, and with the integration in a CAMS system, in models like CAMS system, is really going towards also the quantitative evaluation of the emissions that are there. I go to the future. Meteosat third generation is the big thing we are working on. There are two missions. So one is the imagery, MTGI, that is flying now since 1.5 years. And the second one is the sounding mission that has hyperspectral, so something that is quite similar to YASI. And also there is a Sentinel-4, or the UVV, near infrared sounder. this is just stationary, so it's a big change. And the big change means that you have the possibility to observe the evolution of the atmospheric composition, of the concentration of pollutants on the tropospheric columns over time in every place in Europe. This is an example of MTGI, so of the imager, and the imager has a much increased resolution, both spectral and both in terms of horizontal resolution. And you see here the difference in observing. Again, here is the transport of smoke from the Canadian wildfire over Europe with respect to severity that is the previous generation. Data sets are preliminary. I mean, there have been some difficulties in flight. I mean, this is reported, but I mean, we are really struggling and working to have data sets for the users as soon as possible. The new METOP, that is also EPSSG, so European Polar Satellite Second Generation, I mean, has a huge ensemble of data sets. So with the YASI-NG and also the Sentinel-5, that is the follower of Sentinel-5 precursor that has been mentioned. I mean, providing data with a resolution similar to TROPOMI. And here is an example on how the capability to observe the nitrogen dioxide has evolved during the last decade. And this is really a very, very big step forward in terms of resolution and accuracy. This is the status. So basically, these are the launch dates. I mean, these are still subject to readjustment. There is a question of launchers that is, I mean, is shared also with the European Space Agency. One good news is that we have the integration of Sentinel-5 that is here, and we are also working on preparing the Calval activities with the joint announcement of opportunity with ESA that will come out soon, and the CAMS is a part of this story, and also tools and software to work with the validation aspects. Just as an example, we already have a precursor or proxies for what we may expect in terms of monitoring from a geostationary satellite. This is an example from GEMS that is flying since 2 years, and that this is a comparison, an activity that we are doing of comparison with GOM2, that is one EUMETSAT instrument. I mean, what can be compared and what we can learn with the synergy between geostationary and polar. Tempo is there, so the Tempo datasets is coming there, and Sentinel-4 will be the European part. I mentioned CO2M. That has been quickly introduced, and there will also some words from ESA. So this is a Copernicus greenhouse monitoring mission that is implemented by ESA together with EUMETSAT, and is basically central to the CO2 monitoring verification service that has been introduced by Laurence, and I think you will hear about that later. It basically comes with CO2 observations at the resolution and the precision and bias that are required in order to support the Paris stocktake effort, but also methane, that is crucial, and also nitrogen dioxide, aerosol, and clouds that are ancillary but crucial measurements. So basically, the point is that there is an enormous amount of data sets coming. There is an enormous amount of information, and then there is also a crucial effort that has to be done together with the users. So with CAMS, transmitting the data to CAMS, but also working with the user at European and world level. So basically, we develop activities in data handling and support the users. This also takes form of tools that we develop together, for instance, also with CAMS in terms of Jupyter notebooks, of material to work with the data, and also more importantly in terms of school and events. We have an integrated system of data access that make use of EUMETSAT native system, but also European diocese like Wikio, so the data sets can be downloaded, can be accessed, can be tailored to the user needs, making use of the different platforms. So basically, these cover all the typology of data sets, going from the real time to the climate data recording, records with the systems of API. So for more information, you have the data access hub of EUMETSAT, that is data.eumetsat.int. We work on fields of science and applications. So basically, we have communication in terms of user stories that often make use of integrated usage of observations and example on how it is integrated to CAMS products like this. And also we work on the engagement. One example is wildfire monitoring that is much demanded. The usage of satellite data is not sufficiently uptaken, and there is much interest. So basically, we really work with the national communities that are part also of our council. So basically, these are our stakeholders, and we do this together again with the SAF, with the CNWF, but with both the CAMS and the CAMS component, gathering basically user needs and user requirements in terms of how to integrate observational data sets in the value chain. I will also mention schools, workshops, so something that really goes more on the capacity building. We have a program that is now arrived to the 6th or 7th event, and this is really done together with the ESA and CAMS. So there will be now a school in September that is more managed by Chris. You will hear about that. It will be Nero in Shella, but I mean, I think it's the 6th of a long series. And also more specific events, like for instance a training school on monitoring dust that we also work together with the WMO and with the key partners in the area. Upcoming events, I close with this. We are also working with African Union, so we had a joint event to understand which are the needs in terms of usage of satellite and CAMS products. This was in 2023, and upcoming we have a workshop and a school that is together with the PRIFIA program of WMO in November 2024 to start to address the uptake of the different products for equality by the institution and the service in Africa. It's an enormous work. I mean, there is an enormous need, and basically also as EUMETSAT, we have a regular user forum in order to gather the data uptake and also the monitoring of the needs and also the new policies that are getting implemented, for instance, by the African Union. Last 2 points. We have an event that is also co-organized with NOAA, WMO, CAMS in November 26 to 28 in Darmstadt, and is future focus wildfires, so is the continuation of the engagement with the users in terms of wildfire monitoring. And also we are about to organize an expert workshop on air quality from satellite, so understanding which is the status, which are the needs from national services, and that this is also organized with the auspices, or I mean in collaboration, interaction with the national collaboration program of CAMS that you have heard about, I mean, in order to reinforce the satellite component. So you will hear about that, and this will be online. I stop here, and thanks for your attention, and I am around now or later for any question, any point, and any curiosity you may have. Thank you very much.
Thank you very much for this comprehensive overview of all EUMETSAT is doing and contributing to Copernicus and specifically CAMS. So thanks for that. Any questions now? All clear. All right. Then maybe in the coffee breaks. Thanks again. Our next speaker is Michael Eisinger from ESA's Climate Office. Here again, we all know ESA is a satellite data provider, but again, we do a lot more with ESA, working on the development of new applications, new services, working together on training. But yeah, Michael will say much more about what ESA is doing to help CAMS. Thank you.
Which is the right button to use?
This is going forward.
Okay. Good morning, and thank you, Richard. My talk has essentially 2 parts. The first one is about missions, where we have well-established collaboration with CAMS. And the second one is about what we do in the what was called the Climate Office, which is now the section on actionable climate information, which is a bit clumsy but describes a bit better what we're doing. And there, I think the collaboration is starting, and I know that Laurence is very active in promoting that, and we will have, in fact, a meeting next week to discuss that further, but I will basically show the portfolio of where things are relevant for CAMS. But I have to start, of course, with a mission which is very close to my heart, which has not been mentioned so far, which is an Earth Explorer mission implemented by ESA in collaboration with JAXA, and has been launched 2 weeks ago. Launch and early operations have been very smooth. We have now the 4 instruments in standby, and I hear that today the first instrument is being turned to nominal mode, which is the cloud profiling radar of JAXA. And yeah, very excited. There will be a lot of science coming up from this mission. I will here show only one small aspect, which is the assimilation of cloud and aerosol profiles, which is being done at ECMWF. And that is work which started a long time ago, but this specific activity continued then from 2019 with Marta Janiszkova and Mark Fielding, where they use the cloud profiles and assimilate them, prepare for the assimilation into the ECMWF weather model. And this has been really difficult. It was a more than 10-year development process, but the aim was basically to be ready when EarthCare is launched, to start the monitoring of the profiles, and then later to implement the assimilation into the system. A new activity which has just started a few months ago with Angela Benedetti and William McLean is to also assimilate the aerosol profiles, and that is building, of course, on all the work which has been done for the clouds, but also on work which has been done for Aeolus aerosol assimilation. And there, the system which is used is the IFS composition model at ECMWF. So for the clouds, on the left, so we are using a variety of data. So we're using, because we, of course, in the development phase don't have EarthCare, using Clouds at Calypso data. Blue basically means improvement of the forecast, and you can see even at T plus 120 hours that there is a lot of blue, which is very positive. We are using also simulated data for those aspects where we don't have satellite capability in orbit yet, because EarthCare will have some new capabilities, like measuring the Doppler velocity within the cloud, and separately measuring backscatter and extinction, because it's a high spectral resolution LiDAR. So these data are used as well. And then finally, they are also using Aeolus data, real in-orbit data, which use a LiDAR which is already high spectral resolution, so more similar to what EarthCare is using. For the aerosol, I said it has just started, but we have already first indications that this is really going in a good direction. They are using an aerosol profile product from which is interesting, actually based on an EarthCare algorithm. So there's also information going back from EarthCare to Aeolus, and which shows that the height assignment is improving in the model when you assimilate the aerosol product. So that's very important information for CAMS, the vertical placement of the aerosol. That was EarthCare. Then I go quickly through Sentinel 5P, Sentinel 4 and 5, which have already been mentioned by Federico, so I can be quite concise there. But the bottom line is that Sentinel 5P, as you know, is already used a lot by CAMS. There is active assimilation, ozone, volcanic SO2, and NO2. There is. It has been shown that CO improves the fit of the analysis to the independent data, which I will show on the next slide. SO2 layer height layer height assimilation was activated last summer, and there's a project on formaldehyde. There's also work done on methane assimilation and preparation for that. So this is the plot which shows that the fit to independent measurements is improved when you are assimilating a drop-OMI carbon monoxide. And I can basically skip this because this has been mentioned already by Federico, that AO call for CalVal of Sentinel-4 and 5 is coming out very soon. CO2M, I go also quite fast, so this is, of course, one piece in the set of informations which will be used in inversion models to ultimately arrive at emissions of CO2 and also methane. These characteristics have already been shown. The flight acceptance is expected mid-26, and the third satellite has just been approved. So this was the first part, which was focusing on mission. The second part now, I focus on what we're doing in the Climate Office. So historically, we have been working on a large number, 27 of essential climate variables in various domains. Since 2010, we are still doing that, and that's what's shown on the left, and that's the physical basis of what we are doing. But in the current program, which is called Climate Space, this is not everything. We also then have a part where we specifically have activities to support and verify the UNFCCC Paris Agreement. We, of course, always had and still have an enormously important part where we link observations with modeling. So these two bits are very closely related also to CAMS activities. And then there is activities on cross ECVs, where we just had an ITT and have awarded some activities, and on tipping points, which is coming up in the future. I will now go through a number of activities where we think there is potential for cooperation with CAMS, in particular if we are looking at using data sets which are produced in these activities for reanalysis, because we are, of course, in this area always looking at developing long-term climate data records. So this one is already going on since the start since the Climate Office exists, 2010, and is looking at CO2 and methane concentrations, and using a large number of sensors for that. And in all the activities we do for the essential climate variables, we always have what we called use case studies. So in this case, obviously the measurements are used in inverse modeling for deriving emission fluxes for both CO2 and methane. The next one is looking at a variety of aerosol and ozone precursors, NO2, SO2, CO, formaldehyde, NH3, and glyoxal, and again using a large amount of sensors to stitch together long-term time series. And there are a number of use case studies here as well, and one specifically is looking at the impact of the NO2 and CO data records on the CAMS reanalysis. Then a fairly new one with a fancy name, Lollipop, that is going to use all other greenhouse gases and ozone depleting trace gases, which are not covered yet by other activities we have been doing. So that's in particular N2O, halocarbons, and SF6. So we are now in an area where we're typically looking at Fourier transform infrared sensors, which are listed here, MIPAs, ACE, FTS, hurdles, and so on. And this is a kind of type study. So it's not yet the study where the climate data records are derived, but it's looking at what's available, what is the quality, what are the errors. Instruments should be used for the long-term time series, and this is the preparation for the next phase where we would then add these substances to our portfolio in the climate space. And the newest one related to atmospheric composition is called Medusa. And this is specifically looking at emission plumes and pre-operation system to harmonize and integrate global information on these plumes. I should also mention ozone CCI as a potential source of information for CAMS reanalysis. This is an activity with quite a large number of products from total ozone to ozone profiles from nadir instruments and also ozone profiles from LIMP instruments. Now, looking at atmospheric composition, of course, is only one aspect which is relevant for emissions. The other one is what's coming from the land, and one area is, and that has already been shown in the previous talk very nicely, fires. And the message is basically how important it is to have the high spectral resolution in the fire monitoring, and going from MODIS via Sentinel-3 to now Sentinel-2 in the lower plot, you can then see that this helps with predicting the CO2 emissions much better. And finally, a new activity which is about to start. I think they've just done the negotiations, and it's about to start after the summer, which is very interesting, which is looking at the impact of land use changes on the carbon emissions. The fuel emissions of CO2 are about 90% of the total, and then we have 10% which are land use change, and these have a very large uncertainty. Maybe not so much in the global total, but when you look at the regional level, and the activity will exactly look at regional emissions, and it will combine bottom-up approaches and top-down methods, where you look from satellites and compare the results with the inventories. And it is looking at selected regions which are particularly important for the global budgets, and it's basically 6 regions, 3 of which where the budget is dominated by anthropogenic drivers, where the land use and management is changing fast. So it's all about forests in various regions: Siberia, Amazon, and Europe. And then 3 regions where the environmental factors arising from climate change are dominant. So that's Eastern Siberia, then Amazon forests which are intact, and Arctic peatland regions. So in summary, ESA can offer a lot to CAMS, and we are already collaborating. We would like to increase the collaboration. We have the space fleet of Copernicus. We have the Earth Explorer science missions as well. EarthCare now coming up. I should mention that for EarthCare, we expect that the first data to users will be available about the beginning of next year. So we are now in commissioning, and it takes a while until that's all robust and calibrated and so on. And beginning of next year, you will be able to get the first EarthCare data. Yeah, and I stop here. Thank you very much.
Thank you as well, Michael. Any questions at this point? No, nothing from the audience. I have a question, basically on your final slides. So you said you would like to intensify the collaboration with CAMS, which we also really appreciate and want to do it. Do you have specific ideas or where we can strengthen on top of what we are doing?
I think one specific thing is the take-up of various of our data sets for reanalysis. That's the most prominent one which comes to mind.
So
because we are not, of course, providing any near real-time services, but we establish very accurate and robust long-term data series, which could be of interest. Yeah, and we should look at the portfolio together, what could be used. And the other way around, of course, because we are free to design additional activities in the current program, where are areas where CAMS would benefit, where we have a specific expertise. I should say again that we have moved away from this thinking in the various disciplines, land, ocean, atmosphere, and so on, and try to have this cross ECV approach. And because we are a relatively small office, the climate office, with the relevant experts, this collaboration between the various expertise works quite well, and that's an asset we could offer to the whole discussion.
Okay, thank you very much. There's a question from Federico here.
Yes, thank you very much. It's, it's more a long side question. You have shown among the data set several profilers, limb scanner and so on, and we know that there is a gap. There will be a gap in terms of the capability to monitor the vertical profile for species like ozone and so on. How do you see the possibility to address this? Because this is also crucial for system like CAMS, where you really need to go towards the capability to measure the vertical distribution of compounds.
Yeah, this has been coming up a lot in the last months. I have been at a meeting of WMO in Geneva, the ozone research managers, where it was also highlighted, and it's well known. I don't have a solution. We have a mission in the pipeline for the next Explorer, but it's one of two, so it could be selected or not. There is no there is no guarantee. But yeah, I can't really help on the process of bringing that in, except in all these stakeholders reminding the agencies and the member states all the time that this is a real observation gap. Yeah, and it's already happening.
Okay, well, thanks again, and as you said, we'll meet in the next couple of weeks, I think.
I think next week already.
Next week already, so time for further discussions.
Thank you.
Thanks again. Our next speaker is José Miguel Rubio Iglesias from EEA. He took over from Henrik Steen Andersen, who most of you will remember from previous GAs, but Henrik left it in very good hands. We had our first meetings already. I'm looking forward to your presentation, how EEA contributes to what we do.
Thanks, Richard. Good morning or good afternoon already. Yeah, I took over recently the activities of coordinating what we call Copernicus in situ component recently as well, last year, from my colleague Henrik Steen Andersen. Yeah, with my presentation, I would like you, after two presentations in which my fellow speakers take you to the space, I would like to now take you to the ground, because I would like to highlight the value of in situ data, not only in CAMS, of course, but in general for the Copernicus program. Because without in situ data, the services that we have seen that CAMS offers, the validation, the calibration of the satellite imagery, the satellite sensors will not be possible. Yeah, this slide is maybe too introductory, but when we speak about in situ data in Copernicus, we refer to, let's say, anything which is not space data. Observations, we have spoken here a lot about pollutant measurements or measurements about greenhouse gas emissions, all kinds of observations that, for example, weather stations or observations taken on a balloon, zones. Yeah, you may name it. We also refer to in situ data for reference data, ancillary data, geospatial data, that is used typically for production, validation of typically mapping products within Copernicus, maybe not so much for CAMS and other environmental services. And we also refer to in situ data category which is essential, particularly for calibration and validation of satellites, which is fiducial reference measurements, which my colleagues from ESA and EUMETSAT are very much aware about them, which are very precise and fully characterized independent measurements that are necessary, as I said, for calibration and validation of the satellite sensors. As I said before, in situ data is essential for Copernicus. Essential because we need it for training algorithms. We need it for increasing the reliability, the accuracy of our products, to validate the products, validate the data that we offer via the Copernicus services, and we also provide in situ data as well as observations in its own right, to make sure to be able to demonstrate and to underpin the results of our analysis and our products. And as I said before, in situ data is also necessary for calibration and validation of satellite sensors. I think what is important here to highlight, and we have heard already in previous presentations, the importance of engaging with a number of networks, is that in situ data, like the constellation that we have in Copernicus, the Sentinel constellations, we don't have a Copernicus in situ network in itself. We really need to work with a number of institutions at international level, at national level, at regional level, which are providing this information. What is the role of the European Environment Agency vis-à-vis the rest of the institutions implementing the different services and the space component? The entrusted entities, in this case ECMWF or ESA, EUMETSAT, they are in charge of managing their in situ data and getting access to them according to their needs, setting up their interfaces to get access to it on a daily basis. The role of the EA is really to provide a support to these institutions, as well as to the European Commission, whenever a coordinated approach across the program is necessary. For example, licensing agreements, liaison with international networks, institutions, or for example, supporting the entrusted entities in getting access to specific in situ data. This is the summary of the portfolio of activities that the European Environment Agency, as coordinator of the in situ component, performs. I would focus particularly on two elements here. One is what we call a state of play. A state of play, with that we mean the analysis and overview of in situ data activities across the program. We have recently prepared a state of play report for 2024, which I will mention now in the next slides. And I would also like to highlight as well the engagement with data providers, particularly when it comes to international actors as well. I will just mention a few key elements of what we call a state of play report. That's, as I said, one of the main outputs of our activities, and the idea is to provide the entrusted entities, the European Commission, the member states, an understanding of how is implemented the in situ related data activities in the program. But to do so, we need first to have a kind of an overview of what are the main issues that Copernicus program, and also in particular as well services like CAMS, are encountering when trying to access in situ data. Because as I said, we don't have a Copernicus in situ network. We really need to build on what exists out there. And we find still issues related to restrictions of use, access conditions when accessing in situ data, particularly at national level, not only in Europe, but also outside Europe. We still find problems, particularly when it comes to spatial coverage. There are the so-called data sparse areas, which we need more in situ data for our products. We rely not only on regulatory networks, we also rely on research and innovation activities, and the sustainability of these networks is also sometimes uncertain. That's an issue that we need to consider. And other elements here, I will not go into all detail. We need more historical time series, particularly for our reanalysis activities. We need more timely access. So we really have a long wish list when it comes to in situ data, but I think as well we hear more and more about new products, new services, but this increases the demand on in situ data as well. So how we are proposing, this is a recommendation that the EA has prepared to try to see how we can address these issues in the next years. Definitely here I would say that in order to close the gaps that we find when it comes to in situ data, we really need to push for more open data, not only accessing data, this data, but also accessing on a fair manner that is interpretable, that is accessible, that is reusable, because this ultimately only results in more transparency in our products. We can provide traceability of the results of our products if we can also facilitate the data that underpins these products. We need, as I said, more historical observations. I think we need to do more effort in pulling down more resources into that. Definitely the implementation within Europe of the high-value datasets regulation, which I think is now more or less the moment in which it's really entering into force, that will also have an enormous impact, particularly again in Europe, in accessing in situ data. And I think the value of research infrastructures is critical, and I think we also need to work with them in ensuring that they are sustained over time for the success as well of our activities. As I said before, it's very important to have a continuous dialogue with the in situ data providers, because most of our products are global. We cannot only focus on Europe, we need to go and work, and the services are already having very good relations with a number of networks and initiatives. We can only work on strengthening more these relations and ensuring that their contributions to Copernicus are acknowledged. And thinking a bit more ahead, if I, sorry. Thinking a bit more ahead, what will happen? We still will have to be working on Copernicus over the next few years, but definitely very important as well is to making sure that we have a holistic approach when it comes to in situ data, fiducial reference measurements for the new Copernicus missions, definitely strengthen the coordination and knowledge exchange within Copernicus. I think when it comes to in situ data, maybe having a strategy for in situ data access over the next years, and definitely we can only work more and more with research and innovation activities. As part of the state of, I keep pushing the wrong button. As part of the state of play, we not only give recommendations on how to address the gaps on in situ data, we are also having an overview or providing an overview, of course, created together with the entrusted entities on the different activities, in situ data activities in the different services. I'm not an expert here, so you may excuse me, but definitely with these couple of slides about what CAMS is doing in situ data, situ activities, and looking to the future, I just want to highlight the importance of in situ data for the service, because it's the starting point for the models. It's used for assimilation, for forecasts. It also helps in constraining the regional models. And we need data, of course, on air quality in and around cities, data that is measured by commercial and research aircraft, also data on vertical distribution of pollutants and aerosols. And as I said before, for the Copernicus program, but also for CAMS, this only is possible with the collaboration of national and pan-European international networks and institutions. And the same when it comes to greenhouse gas observation networks, with the total carbon column observation network, FluxNet, ERCOR, and so on. When we look at the future, again, this is work prepared together with the colleagues from CAMS. Of course, the new sentinels that we have heard before, the new monitoring verification support capacity, again, this brings more demands, or drives more demands for in situ data. And there are a number of challenges, and of course, funding more data about aerosol size distribution, vertical profiles, we've heard before, more timely observations, and especially as well, more data outside Europe are necessary. But of course, there are a number of opportunities. We know there exist. There is more and more data available for locations representative of air quality exposure level. CAMS is doing great in engaging with observation networks and science community to provide feedback to them. And of course, new applications as well will be benefited from validated in situ observations as well. And of course, the use of air quality greenhouse gas observations will improve the emission inventories. And we mentioned before on different presentations, I can only highlight that, of course, the successful implementation of the MVS will depend on necessary accurate in situ observations. There is a green report there that dwells into all these details. Just a few remaining slides about our work by the EA in support to CAMS and in support to Copernicus. The EA supports the different entrusted entities thanks to a few consortia of in situ experts, particularly in this domain. And the consortium is called COINS and is led by UMetNet, together with the NILU, which is here around, who are those helping the EA when it comes to atmosphere, and as well Eurogoose. We have supported CAMS in the past with reports on the in situ data for CO2 MVS. And that you can find the reports there. And currently, in the contract that we are running, NILU is helping the EA in order to facilitate the accessibility, or let's say to find out all this homeless data that are not really still in fair repositories where they can be used by the Copernicus services and the Copernicus entrusted entities to be readily available. And I mentioned here a few examples of work of trying to make available rescue time series of ozone, UV measurements, now on the validation data center, and that is used by the Sentinel 5P. And also we are now working on data from research vessels. Of course, coming from the EA, I could not stop referring to one of our key contributions to CAMS, even if I'm not part of the team working here. But CAMS has a contract with the company implementing the regulatory air quality data management of the EA. You can find here the link to the air quality portal from the EA. The network, which comprises a total of 10,000 stations, although around half of them provided validated data in 2022, 3,700 stations delivering now up-to-date data in this year, with measurements from, you see particulate matter, SO2, NO2, ozone, and so on. And of course, one of our stars that I have heard already a number of mentions today, the air quality index that also benefits from CAMS as well. And this data that is provided by our network, the IONET network, is used for CAMS model assimilation, verification, validation, and reanalysis. Just before I conclude, again, I think it's important to highlight the gaps that we still have, particularly when it comes to data outside Europe. The EA is trying to support ECMWF and the rest of the entrusted entities in trying to facilitate access to these non-EU countries. So we have a list of all the different type of requirements, in situ data requirements that the different services have. We implement this in a series of international arrangements with non-EU countries or with any international partners. Whenever we have the occasion, particularly for CAMS, we have a list of in situ data requirements that you can see on the screen, which we try to get access to, so the colleagues from CAMS can use it in their work. Just to finish my presentation, if you have more interest about what we do at the EA in terms of coordination of the in-situ component, we have a website which is currently under revamping, where we will be publishing a number of reports, the state of play that I just mentioned before, a number of use cases, as well as a comprehensive list of data providers, of in-situ data providers in Copernicus. So I think that's all from my side. Thanks, and happy to respond to any question.
Thank you, Jose Miguel. Any questions? No, all clear again. I have a question. You mentioned the CO2 MPS, which is now being implemented, and the green report, which specifically talked about the in-situ component and showing how important it is as part of the overall system. Do you see specific challenges there on the in-situ data access, data availability?
Yeah, I think there are a number of recommendations there. I will not go into all the details, but definitely it's so critical, the access to in-situ data. There are still a lot of gaps in accessibility to this in-situ data, and I think there is a lot of work yet to do there in that context. But I really invite you, everyone, to have a look at the green report, and yeah, we are happy to support CAMS in the future on the implementation of that service. Yeah.
All right, very good. Thank you. No further. Okay, thank you. Then our final presentation, we will zoom out a little bit. We have been quite European focused, but CAMS also contributes to international frameworks. One of them is GEO, and our next speaker, Thierry Ranchin, will talk about the EuroGeo activities that try to link European data sets, especially from Copernicus, to the global initiative that GEO is. Please go ahead.
Thank you, Richard. I hope you are not too hungry and you are still alive and ready for the last presentation of this morning. So I hope you will still have some attention on what I'm going to propose you. I'm not going to talk a lot about science, but I would like to talk about structuration of the EO ecosystem in Europe through the combination, coordination, and cooperation of the different European strengths in Europe, for Europe and toward GEO and vice versa. So there is a logo here, One Euro Geo, that is really what is underlining what we try to do. It's really to be an inclusive driving force in advancing the EU capability, to try to build a community and a sense of belonging to this community in order to contribute to a sustainable and resilient EO ecosystem. So, for those who are not aware about GEO, on the last presentation of this session, at least in most of them, you see this GEO logo somewhere that is composing the EuroGEO logo, and all the different speakers talk about the international cooperation. It's where EuroGEO appears and where we can bring something. So GEO is the Group on Earth Observation. It started in 2005. It started with the building of the Global Earth Observation System of Systems, and it's an intergovernmental body dedicated now to co-produce user-driven Earth intelligence solutions. That's the future of GEO. It starts with data, go to information, and now to services. We are in the preparation on the new work program, and so it's something where we can influence also the different pathway toward the future of GEO. What is GEO? It's composed about 116 members, so countries, but also more than 151 participating organizations. In the last 5 years, we have worked in a project called eShape, EuroGEO Showcase Application Powered by Europe, to exploit the Copernicus datasets, including CAMS, in order to develop user-driven services. The idea was really to have a sandbox where we can test a number of ideas, building on what will be the future of exploiting of all these data that are coming out from Copernicus. And so, in this sense, we are now defining the new version of EuroGEO, trying to develop what we plan to do and to give a strength to the European EO ecosystem to develop more and more. So, in a nutshell, EuroGEO is a regional GEO. It's a regional GEO initiative. There are 4 in GEO: Asian Oceania GEO, Ameri GEO, Afri GEO, and EuroGEO, the last that had been set up in 2017. So here you have the key ideas of what we plan to do in this. It's through combination, coordination, and cooperation in order to deliver European contribution to GEO as much as possible integrated and to increase the GEO benefit for Europe. So we are in the idea of acting as an incubator to produce and test EO services and application in cooperation, to deliver this application using integrated global datasets that are existing in GEO, but also in Copernicus, in European country, and at national level, and to promote scaling up and develop this EO application in association with users. There is really this need of users in our activity because they are the ones that can support the user uptake of Copernicus at large. And so we are building on Copernicus, of course, and on all the European projects supporting GEO. And so, of course, we have the different engagement of GEO and the implementation on focus and pushing for this. So, The objective of this project, so Eurogeo, I've set up a Eurogeo Secretariat project that I'm coordinating with the idea of really setting up a Eurogeo Secretariat for the long run and to support the Eurogeo initiative on the long run with a sustainable schema that will allow to have action on the long run. So the idea is really to coordinate, support and facilitate the smooth implementation of the Eurogeo initiative activity. CAMS is part of this large cloud of activity, but it's somewhere under the flotation line in order to support all the activity, and there is a need to really push that on the light, and so we also have to build an evidence-based framework that supports the prioritization of research and innovation in Europe. That's part of our duty in this project, and to support the planning, execution and monitoring of the Eurogeo implementation plan that contribute to the geostrategic plan and to develop research policy guidelines and standards. So the concept, we have also to reach a sustainability concept, of course, but that's part of another story. So what we plan to do, so that will be a complex schema, but I will try to guide you on that. The future of Eurogeo is not taking care about that, which is a sustainability concept that have to build a strategic and an action plan to support the Eurogeo implementation plan sustainability and also the Eurogeo Secretariat sustainability. The 3C concept, combine, coordinate, cooperate, is really the link with the community. There are in Eurogeo action groups, so a group of users comprising researcher, industry, infrastructure leader, etc., that are building in thematic area. They are here listed on the back of the slide. And in our activity, we have this coordination support to provide to this action group in order to support them and to help them to develop their idea and also to extract from them the challenge and the gaps that we will have in the research and innovation impact. I will come back to the top of it. In this liaison activity, we are talking with partnership networks project, but also with industry, with all the European infrastructure, and also with all the interested entity and EU body. And thank you to inviting me to present here, because it's part of my duty to also explain what we have in mind and what we would like to build with you as a sustainable EU ecosystem. So that's part of the 3C approach. The research and innovation impact is really to build on what we have done in eShape, supporting new services, to support innovation, to support market development, and to also extract all information that we can for research and innovation through the Research and Innovation Observatory that is set up here. And of course, as any body who try to promote the building of an ecosystem, we are talking about communication and outreach, and we are in duty to organize the Eurogeo annual events. I will come back to that later on. So, what are the impacts that we want to have on the Eurogeo initiative? That's really to strengthen the geo-related coordination mechanism. We saw the logo of Geo in any of the presentation in this session, and so we have also to coordinate all of this. To reinforce the support to increase innovation, space application development, not for the core service of Copernicus, of course, but for the user uptake that is supporting also Copernicus. To reinforce the space data ecosystem concept within Europe. There was a presentation from José Miguel talking about in situ, but we have all in mind the fact that finding data sets are complex and not easy to access, apart from the CVS format. But let's try to reinforce this data space and to pursue the international cooperation to stimulate the market and promote the European technology and services. of course, to contribute to the European Green Deal through the deployment and exploitation of Earth observation, also in regulation and also in support with the different DG that talked this morning, because of the inclusion of the Knowledge Center for Earth Observation in our group. So here is the link to our Eurogeo Secretariat website. So we start in the 1st of December, so it's building, and in this you will have soon, hopefully, a page for all the action groups that will explain what they are doing and will explain the committee behind that, and you will find a lot of information about what we are doing here. And also a series of information. We have a presentation, I don't remember if it was UMETSAT or I think it was UMETSAT talking about Knowledge Hub. It was you, okay, thank you. And there is in Geo a Knowledge Hub, and we have done a lot in the previous project, presenting the 37 pilots that we have developed in 7 domains that start from agriculture, health, renewable energy, ecosystem, water, climate and disaster. And we have put also a lot of information about the output of this project and the output of the Eurogeo initiative as knowledge granular, given access to publication, to services, to access to these services, to data sets, etc. And you can explore it really easily. And there is this Eurogeo community, and we hope to increase the visibility of this action. On the same place, you will find also the Space Climate Observatory that also built its own community, delivering all the activity from the SCO. And last but not least, we are preparing the Eurogeo workshop in 2024 that will be held in Krakow in Poland, and where we have also to work on the development of this Eurogeo implementation plan, engaging and onboarding all the community in this activity. You are more than welcome to come and to contribute to it, and I know that some of you are going to do so. And last but not least, I tried to imagine what we can do together. In fact, of course, you can contribute to the action group and to the future geofocus area that are under construction. We have built a questionnaire that tried to have your feedback and the feedback of the community on what we are planning and the different ideas. So if you have an interest in what I've explained now, you can take a look to this questionnaire and access to it to give some feedback. And also you can contribute to the Eurogeo implementation plan. I just write at the end what are mutual benefits to work together, but I think I noticed some ideas that I want to share with you. The use of CAMS and Copernicus in the geo community is large, and most of the countries that are using Earth observation data are using Copernicus data. So the idea that we can share together, it's really to increase the impact of this data set, of the data set that you are building and that we are building, and to increase also the user uptake of this data set. We can also share the findings and methodology that we are developing in Eurogeo with the community and vice versa. We are keen to have your feedback also on what we are developing and what you can, how you can support us, and really to bring back to you the user needs coming from the geo community and really support the development of the action, not only from the research point of view, but also from the political point of view. So thank you for your attention. I hope you can come to Krakow in October, and feel free to contact us and to open the discussion. Thank you very much.
Thank you very much, Thierry. Any questions?
No, too close to the lunchtime.
I have a small question. You shared the link. Is this also available through the website, or?
Yeah.
So people can just have a look at the website and see how to engage.
No problem, and if you don't find it, just send an email to contact@eurogeosec.eu. We'll answer to all the questions.
Okay.
Thank you very much. My colleague Nicolas Fichot in the back, if you can stand up, Nicolas, is also here for the rest of the day. I have to leave, unfortunately, but if you have any question, you can also discuss with him. He will be here for the rest of the day, and maybe also a bit more. Thank you very much.
Thank you. Then I'll answer the final question from the audience. Yes, lunch is being served, both on the ground floor and the first floor. So this, you don't have to queue all together. We can distribute each other among the space we have. We'll reconvene at 2 o'clock, sorry. I'm still in UK time, right? 2 o'clock, so enjoy the lunch. Please keep engaging with each other and enjoy the food. See you in the afternoon.
So it was a request made by some of our users to have a workshop dedicated to dust and air quality. And we saw that actually is not only a specific type of user, but everybody is concerned by this subject. So today we have a session dedicated to it. We will have this session divided in 2 parts. First, we will have the intervention of some of our users. Then it will be followed by the expert. We will have a Slido question on parallel that will be done. You will have to answer it after all the talk. But if you want to already connect to the Slido, you can do it now to save time for later. If no more question on the subject, I will now move to the first presentation from our users. So we have selected 3 national experts to talk about how they're using the dust and air quality data and what kind of difficulties sometimes they can encounter to use this data. My first presenter will be Vasilis Amiridis from NOA in Greece. Vasilis.
Good afternoon, Vasilis Amiridis from NOAA. I will speak as a user, but also as an expert, let's say, that will try to improve somehow the national collaboration program and how we forecast dust in Greece specifically. You also all these nice plots the previous days on how Greece has been affected by desert dust episodes that for the last 2 years have been increased in both intensity and frequency. So what we are going to do is to use some new data in order to help models better predict these events. And the plan is as follows. First of all, I will show you in my presentation some new dust products from remote sensing, UV and visible, basically from active remote sensing, but also passive. Then, how this data can be used in data assimilation in order to increase the accuracy of the forecasts. So I will start with a basic LiDAR system that we operate in Actris. Actris is a European research infrastructure that operates aerosol remote sensing facilities. And this is a standard system with 3 backscatter, 2 extinction, and 2 depolarization channels. You see easily here how well we can discriminate dust. We have extensive properties like extinction profiles, backscatter profiles, and then it gets to intensive qualitative properties that you can distinguish then the aerosol type, right? For dust, you can see that you have low angstrom exponents. This is well known, but we discriminate dust using the depolarization ratio here. And of course, we have the LiDAR ratio. So if you gather climatological observations from this network, you get a plot like that with the intensive properties. In the x-axis, we have particle linear depolarization ratio, and in the y-axis, you see the LiDAR ratio. You can see easily where dust lies. It's within this side of the plot where we have high depolarization ratios. This is because you have non-sphericity. The non-sphericity of the desert dust particles is the reason for high depolarization ratios, right? So what we do in terms of aerosol typing is to separate using these plots in order to separate the type. So you have non-dust types in the low depolarization regime. So these can be fine, strongly absorbing, fine, less absorbing, and coarse mode, non-absorbing, like the marine, the sea salt in the bottom. And here you see the dust, as we said before. So we assume that all the in-between values comes from external mixtures of dust with other particles. So having this model and assuming these depolarization ratios, we are able to distinguish dust. You see here actually a retrieval of the mixing ratio of dust in the dust volume, okay? So this is a solution to separate desert dust in external mixtures. Even when you have mixtures, you assume that you have pure dust for above 30% depolarization, non-dust for lower than 5%, and all in the between is a mixture, but you can discriminate, and you see the result here. We have a profile of extinction, a depolarization, and how we get the dust in the free troposphere. Then in the boundary layer, you see also some anthropogenic contributions, okay? So this was the methodology. We validated this methodology, we applied it in Calypso. And you see here an overpass of Calypso and an underpass, underflight from the Falcon of DLR. And this is a layer, an elevated layer of pure dust with mixing ratio of almost 1. And this is a lower layer that you see that the mixing ratio from electron microscopy of filters collected with Falcon is of the order of 0.6. So we have a mixture with other particles usually found in the Mediterranean. And if we apply, however, here you see that Calypso discriminates dust only. So if you apply the methodology, you get similar ratios, mixing ratios for dust as are in reality. So if I already convinced you, you can go for some applications. This is the third dimension on how to separate dust. You see here Calypso and how we removed other particles. And this is the 2D distribution, a climatological distribution. You can easily see how, from the total AOD, we get dust AODs that lie within the dust belt. And this is some applications you can run, for example, trends over different regions. We believe that we have a positive trend in Greece, but still it's up to 21. We will study that with CAMS. And this is another product, for example, the deposition, dust deposition, to study biogeochemical cycles from iron in the oceans. And this is a work we did in an ESA study called DOMOS with ENSA and Geronimo. You see here the Godzilla run, and when we assimilate dust profiles, how we improve the dust load in Barbados. We have a validation in Barbados here. So coming to NCP, first of all, we have an experiment in the CAMS, in the global model, where we will be using EarthCare. EarthCare is coming, is a satellite, a European satellite with a lot of data to be provided from that system. We have extinction profiles, we have backscatter profiles, and also depolarization. So from that, we will get dust profiles from EarthCare, from the total extinction measurements. So in the EarthCare disk, we have a study of ECMWF running CAMS. We will provide the methodology and also the operators in order to improve dust fields within CAMS, the global model. And we have some plans to use also EUMETSAT information from the polarimeters, the multi-angle polarimeters, new systems that we will be launched soon. And at the end, for the NCP, we focus mainly on the ground-based systems. We have already a monitoring activity where we test CAMS, we test these measurements for CAMS assimilation, for regional model, for our model in NCP. So this is the representativeness of the ACTRI stations. You see here a coefficient of variation taken by climatological values using Calypso. And you see that most of these systems for a radius of 200 kilometers are representative. I'm talking about the ground-based LiDARs in ACTRIs that can be used actually for data assimilation. And this is what you get from this system. Actually, the resolution, we all know that the spatiotemporal representativeness is higher for a satellite and lower for an in-situ system. But for these systems, the ground-based remote sensing, we see that varies and can be applied for different model resolutions. Okay? So we have one action in CAMS 21B with Lucia Mona, where we can assimilate when we have a large representativeness. and in CAMS NCP when we can improve the regional forecasts. This is the method how we do it. We will be using this station. This is the total extinction variability, and this is the dust extinction variability. In general, for dust, we see less variability, of course, because this is a large-scale phenomenon and is not affected a lot by distance. And this is the monitoring activity in our CAMS NCP in Greece. We have a LiDAR station here. This is the CAMS forecast. This is the CAMS forecast with the dots here, the stars, and this is the vertical profile of the dust derived with the methodology I described. So this is a very nice performance of CAMS for this case. So the next steps for the NCP are to use the initial and boundary condition for CAMS, run our regional model, and apply methodologies for the assimilation. Sorry, I lost that. How can I go back? I cannot. It's the red. Okay, so the idea here is to use the layering from the LiDAR to shift the layer in CAMS based on new assimilation methodologies, and also to use the depolarization as a mixing ratio profile in order to assimilate the dust per se in the model. So the final streaming will be that after this assimilation, we will provide the data in our website to inform people, and also time series for the different regions in Greece in the framework of the NCP in order to inform for the new Saharan dust episodes that we experienced lately in Greece. Thank you very much.
Thank you very much, Vasilis, for this presentation. Is any question for Vasilis? I think it was very clear, so thank you very much, Vasilis. Our next speaker is coming from Iceland. So Pavla, if you can come and explain what you're doing in your country. Thank you.
Yes, so good afternoon, everybody. It's a great pleasure to be here, and I will actually take you to higher latitudes and polar regions because these are vast areas of deserts as well, which produce quite high amounts of dust. So the presentation is on behalf of me. I'm from the Agriculture University of Iceland, and my partner in the NCP Iceland, Michala Hrabalíková from the National Land Survey of Iceland, and our partners from the Serbian Hydrometeorological Institute and also WMO-SDS, which stands for the World Meteorological Organization Sand and Dust Storm Warning and Assessment System. So with the NCP, here we are. I just want to, this presentation would apply for the whole Arctic region, but here I'm just focusing Iceland because that's the place I know the best and have done research there. But when it comes to air pollution, there are vast sources as well. It doesn't only come to the local deserts, but also, for example, active volcanic eruptions, although they are, for example, without volcanic ash, you have other air pollutants. But the country, although it's more than 3 times larger than Belgium, still has a very poor monitoring system. So what is available is on the left side from the Environmental Agency of Iceland. The in-situ measurements are located mainly in the capital cities in Reykjavik or in the north of Akureyri, and the other green points are rather for the SO2 measurements than particulate. So what is happening is that although Iceland is reported as one of the cleanest air country in the European Union, these data are only based on remote stations from the deserts. So that was the main topic to show in our NCP, that these deserts should be monitored as well, and we should have more tools how to raise awareness on this issue in Iceland, but also, as I mentioned, for all the polar regions. So here on the right you can see the maps where you can see the deserts, which are actually of larger area than Belgium itself, and on the next slide, that will be the next map actually we will provide for the public. And on the next slide, you can see the 3 new stations we have established around the deserts. And here is just some example of the data. So, for example, the Hafnarfjörður resource station in Reykjavik, one of the so-called cleanest in EU, is showing mean PM10 for the annual track or record, something about 5 to 7 micrograms per cubic meters. I don't remember exactly, but from this remote station in South Iceland for this 10 days period, you can already see that the means are significantly higher. And also, we are keen, because Iceland has extreme conditions to measure in situ, very strong winds, rain, snow, basically really bad weather. But we are also, so you have to allocate at least 2 instruments, and we are also keen on providing the particle number concentrations, which are generally actually omitted from the EU legislative, but they are as well extremely important for health, for example. So we have also the slide aerosol optical counter, which provides a number concentration in 19 size bins, and also the type of the particulate. So on the top graph you can see the brown color stands for dust based on laboratory measurements. And now the comparison, so now we have some data finally for the in situ measurements, and for the modeling part or forecasting, which is not really existing for high latitudes, except the Finnish SILAM model. But for Iceland especially, we have an operational model, Dream Iceland, that's based on our partner group from the Serbian Hydrometeorological Institute and WMSDS WAS. And from that, for the same period, I was showing the eastern dust storms in April. We have the forecast here, which quite well actually agreed with the in situ measurement, at least for the southern station. But then we can see something on MODIS, like AOD is increased south of Iceland. But when we look at the CAMS dust prediction for this 3 particle date, you can see it's only for low latitudes, so nothing from Iceland. So to answer these 3 questions here, how we are experiencing the CAMS dust data or PMT data, so the answer is not very positive, because when we look at the mask for dust for CAMS, actually for the whole April there wasn't even single spot, and we know these even from the true color satellite images that these events were massive and the plumes are visible in several hundred kilometers from Iceland. So, and the resolution is also not as actually would be preferable. While the Dream model actually is really based on this dust sources in very detailed parametrization. Yeah, so that would basically answer where are we standing now, but for the future, of course, one of the ideas would be maybe to implement both Dream and for the Arctic regions generally, maybe SILAM dust forecast for into the regional forecasts of CAMS. And I guess that was the last slide here, some images of the new in situ measurement stations. Some of them were actually buried by sand dunes just within 2 months. So it's a harsh environment, but we will make it. Thank you.
Thank you, Pavla. It's nice to see that actually having the National Collaboration Program is helping to have better discussion on between Iceland and the CAMS service and see how we can make it happen. Is it any question for Pavla? Yes. Is it?
We would like to include a high latitude dust in the global model. We're working on that, and we'd be very happy to collaborate maybe with you. And I would like to know if it's possible if the data you show is more or less public in terms of observations.
The max is coming.
Yeah, well, exactly, to have the data available, that's what you are asking. Exactly. From the in situ measurement. That's one of the key points of the NCP, that everybody can use it. We are still having this first map I was showing in progress. That's going to be the main result, hopefully in less than 6 months. But yeah, that's one of the keen interests, to share and have it freely available.
Well, thanks a lot. And I would be also very interested in this dust source hotspot that you're showing, because we miss indeed this information in the global, and your local expertise here is really valuable.
Well, we can provide it based on the Agriculture University of Iceland source map, but there is also for the United Nations UNCCD Coalition to Combat Desertification is a global sand and dust storms source-based map, and they luckily included the high latitudes after our request into it as well. So that's where you can find kind of intensity of sands and dust storms annually or selected seasons. So I can provide you with that link if you want. Normally I have it in presentation, but shortly here.
Okay, well, thanks a lot.
Thank you very much, Pavla. So I'm sorry, but for the sake of time, sorry, we need to continue to move on, but it will be a bigger session at the end of this session where we can have all the Q&A for everybody. So my next speaker is coming from Meteo Bulgaria. It's Elena. So please, Elena, give us your point of view.
Good afternoon, everybody. I have the honor to present our activities on this related CAMS products of my group. We have several activities on this, and the first one is started with elaboration of methodology of assessment of exceedance of PM10 daily limit value. And it was developed upon request of our Executive Environment Agency, and also was used for reporting to TA for 2022 and 2023. We're still working on testing and improving. In parallel, in our forecast department, we produce a daily bulletin on this transport possibility of this transport over the country, which is every day is distributed via email to the ministry. And the other due to great increasing interest of this intrusion events over the Bulgaria, we decided to set activities under our project in NCP. And now we show a forecast on two domains, on domain Balkans, like dust concentration of 3 different levels as hourly and daily basis, and also as DOD also on this domain. And the second domain is for Bulgaria, where we're presenting data for PM10, PM2.5 also, and dust, again on 3 different levels as hourly and daily basis, and we extract at points. These points are official air quality station in Bulgaria. Because we would like to do a verification, this is the next step. And the one also very important activities for us, and when we have high pollution episode during the analysis, we are also use several CAMS products. This is the data from regional and global model for policy support tools, GFS data, of course, with additional sources which are listed here. During these activities, we have, of course, different challenges. Two of them are presented here on uncertainty of constancy results for those for Bulgaria, and also how to verify the result of the methodology on exceedance. And here we presenting some thoughts of our group, how CAMS can help for our work. So if it's possible to provide the guidance and recommendation on methods for subtracting this from PM10, it'd be great. And also probably maps for probability of exceedance of daily mean PM10. Thank you for your attention.
Test. Okay. Thank you very much, Elena, for this nice presentation. It's again a nice showcase of how the NCP can make the link on between the National Institute and CAMS. Is it any question for Elena before we move to our CAMS expert? No, I think it was perfectly clear, so thank you very much, Elena. So now we will move to our CAMS expert, who will explain how we can help the user on the aerosol and on the air quality subjects. So our first two speakers are Mark Farrington from ECMWF, who will talk about the monitoring of the dust events, followed by Augustin Mortier from Met Norway, who will talk about the dust alert.
Okay, thanks. Okay, thanks, Julie, and good afternoon. So I'm going to start off setting the scene a little bit by talking about what we mean by monitoring within Copernicus Atmosphere Monitoring Service. So it's a very sort of high-level overview, but hopefully it makes the connections to what the following speakers will present and what we already heard this morning in the overview from Laurence and others. Okay, so within our section at ECMWF, we have a mechanism analyzing and diagnosing atmospheric composition events and episodes. We have an internal space where we have this compilation of many studies related to fire emissions. Desert dust is a key part of that. So you can pick out here, month by month, Saharan dust episodes in current month. In May I was on leave, so there isn't any there, but in April and March also there are cases looking at Saharan dust, and many months throughout the years that I've been running this weather room, a lot of cases looking at dust. And I'm just going to focus on, thank you, just going to focus on issues or episodes affecting Europe. So to give you a sense of a workflow for doing this monitoring in near real time, it's based on a lot of the things that have already been presented and I'm sure everyone is aware of. So the aerosol alerts, looking at the forecasts, and with these Saharan dust episodes, it's bringing together the ensemble and the global forecasts, looking at dust concentrations, aerosol optical depth, comparing forecasts and analyses. Some on-the-fly evaluation. We have a number of tools that have this near real-time evaluation capacity, which then gives us a sense of how reliable things are. One of these is the CAMS validation service, which Augustin will talk about next. And then there's additional information that's added more or less on an ad hoc basis and will be added more routinely. So satellite imagery feeds into the validation activities, looking at concentration, deposition, fluxes, meteorological and atmospheric impacts. And then at the end of this so all of this is aimed at identifying potential issues, where the forecast is doing well, where it's not doing so well, and why. But then also there's this kind of storytelling dimension and dissemination through social media and the website and to the media. So I have a quick example to illustrate this. These are dust, in December 2023. So we see on the left the aerosol alerts, and these orange is where the dust aerosol optical depth is above some climatology. On the right then is the forecast, the aerosol optical depth from the forecast for the same day. And then often we bring in things like the Copernicus image of the day, which looks at, in this case, this is this dust off the coast of West Africa between the Canaries and Cape Verde. And so we can see that there's good correspondence between these three. And then we can do quick evaluation. So these are Aeronet sites at Santa Cruz, the Tenerife, and Cape Verde. And the blue dots are the independent observations from Aeronet. And we see this reasonably good agreement in the timing magnitude of these plume events. And then also we can look at sort of broader context by looking at a time series or animations of the analyses, which then show the extent of the transport. And this is then, of course, all based on the observations too. And then the end point of some of these things is a website article or a press release or a social media post. I'll come back to that. And then I'm just going to step through a couple of other cases quickly. So this is something similar. So this was in beginning of March of this year, so the usual kind of plots that I just showed. Here there's an example then of looking at the dust deposition rates and for dry deposition, wet deposition, and sedimentation, so we can start to use this information to look at the surface impacts a bit more. Another case here, this is the 26th of March, so we have the global and regional forecast. The color scale changes a bit here. But again, the same as the previous slide, more or less, with the Aeronet sites here, and these in the central Mediterranean. And the point here is this is then looking at how do the forecasts, what is the lead time for the forecast, how accurate are they compared to then what the analyses show. So this is just an example. The shading is the analysis valid for the 26th of March, and the blue lines, if you can make them out, are then like the forecast lead times up to 120 hours or 5 days. And so the shape of the blue lines pretty much matches the shading, and so this is, I would say, in the cases of dust, Melanie might tell us something slightly different for some cases, but overall the pattern and distribution magnitude is captured quite well, even up to 5 days in the global forecast for AOD. We can also link this to send the policy products, but I'm not going to talk about this. And then there's another case here, which is then the 30th of March, and this was to show, well, so the link to the validation server that Augustin will talk about next, also some in situ sampling, inadvertent in situ sampling that I did hiking in just south of Trier here in Germany. This arrow should be down in the south of France, but this is one of our colleagues' cars while he was on holiday there. And then this brings us up to this case. So Laurent showed this morning, and again, very similar to what I've been showing, just to show we have multiple of these events, episodes analyzed, and also in near real time. So this is information put together yesterday and this morning, and has resulted in a website article and press release. And thanks to colleagues from Greece and Cyprus and Bulgaria for their inputs. It's a nice case of bringing everything together to show this collaboration across the national experts through the NCP to link to then these global products. So this has been a really nice example, a really good opportunity to do that while we're all here in Brussels. And then finally, dissemination communication. So I mentioned all of this before. So Twitter and other social media platforms get good engagement when we show these animations of the forecast, particularly for dust. A couple of website articles from earlier this year, so which you can find. And then also the last thing, this wider kind of outreach. So we have a series of podcasts, and this was a really nice thing to do. We worked with Sarah Bassat from WMO, Elena Ruiz from DLR, talking about different aspects of Saharan dust transport, why they happen, how the frequency is changing, how we monitor it, and what it means for then the solar energy sector. And so there's a lot of communication that builds on this near real-time evaluation and monitoring of different episodes, which I think contributes to the success of our communications, but also then the service and the visibility that we're getting. And we saw that this morning from the people from the DGs and the other overviews that we get a lot of, we have a lot of success in CAMS, and this is an essential part of having that. So thank you. I'm done.
Hello everyone, so my name is Augustin Mortier, I'm working at Met Norway, and I'm going to introduce you to the CAMS Aerosol Alert Service that was just mentioned before by Mark and earlier this morning by Laurence. So the Aerosol Alert Service is an online tool which provides to the users forecasts of aerosol extreme events based on the IFS OSUIT forecasts. As you can see in this screenshot, we work with several parameters. So here were 8 different parameters. You can already see here, on red, we have alerts attributed to sulfate aerosols. In the shades of yellow, we have dust aerosols. In green, organic aerosols. In blue, you would you could look at sea salts and in black carbon. So those aerosol alerts are computing using the species optical depths. In addition, we have alerts for the total optical depths and also for using the PM10 and PM2.5. So that's 8 parameters. Those alerts are available up to 3 days in the future, so you can use the time slider at the bottom and look at the different forecasting days at 3 hourly resolution. So I will use most of my time in this interface showing you the different options you can play with, but before that I just have 2 slides showing a little bit how things work behind the scenes. So we are using this PyAirAlert Python library designed especially for that purpose, which reads in the CAMS analysis data, the IFS OSU data, so for the 8 variables I just mentioned before. And using that, we compute the alerts for the model. We also use observations. So for Aeronet, we use the AOD, and using EEA data, we are collecting PM10 and PM2.5. And using that, we are computing in the similar way the alerts at the observation sites. And the interest, of course, when we do that, is that we can collocate the alerts computed from the model and from the observation together and evaluate, and use these collocated alerts for evaluation purposes. If I manage to go back to the previous slides, you would see that there is another functionality of this service, which is, I cannot, but there was just one box left, which was mentioning email. So that's not working well. So you can go to the website, define a custom alert, and if a forecast predicts an alert within the area of your interest, you can receive an email. The previous slide, this one, So we are talking about aerosol, but this is how we define those alerts in this service. So we have 4 different levels. So 3 positive levels, 1, 2, 3, which are related to different intensity of events. For the alerts using optical depth properties, we are using relative thresholds, which means we compare the value of the forecasts at a given location against a climatology computed from the CAMS analysis at the daily scale. And if the forecast exceeds, like in the case of the total optical depth, 3, 4, or 6 times the climatological value, then we will trigger an alert of level 1, 2, and 3 respectively. For the species optical depths, we use slightly different thresholds. And for the PM-based alerts, we use absolute. So now you know a little bit how the system works. I will show you live what the system looks like. And because we are session, sorry. I will use a dust day to illustrate this service. So this is what it looks like. So you will find most of the user options menu here. By default, as you can see here, you visualize all the alerts for the different species. It's possible to visualize the alerts for the species individually. You can look at the alerts using the total optical depths and also the PM10 and PM2.5. And because those surface alerts are computed using absolute thresholds, of course, you will have a lot of alerts in the dusty regions or the polluted areas. You can visualize, if you're interested into the alerts around the poles, you can switch to the 3D view. Looks also kind of nice. You can, for a quick evaluation, you can add the satellite pictures. So that's MODIS, that's VIRS. Let's go back to the 2D view and zoom a little bit over Spain, where the major dust episode was happening. And you can see, yeah, if we stop a little bit, you can distinguish here the dusts, and it looks like the model was predicting a dust plume also in the same shape, I could say. If you select here total aerosols, you will unlock this Aeronet button. So yeah, we can Aeronet provides total optical depth, so we can compare for that specific parameters the alerts computed from the model and from the observations. So if you select this Aeronet dataset, you can see some dots will show up on the map. And if I stop at the right time, so here we have blue dots. So blue means true positive. So it means that there was an alert detected both in the model, as you can see here with the polygons, but also at the observation station. And if you click at the station, you have a quick view of the values. So you can see that the absolute values were not exactly the same between the model and the observations, but they were still both above the thresholds. If we look at another time, like here, we can see here there is a circle with a gray color line, which means a false negative, which means that the model did not produce an alert when there was actually an alert at the observation site. And here you can see that actually the model and the observations were pretty much in line up to midday, but at 3 p.m., it seems that the plume passed over that observation station, but it was a bit late or not at the right place in the model. So that gives you a quick evaluation of the forecasted alerts. You can also, if you select the concentration here, you could have the same kind of features using EEA data. So the last thing I wanted to mention, of course, is this email service. So if you create an account here, you can create a custom alert. So let's give a title to this alert. So if I'm interested in, it's difficult to write with one hand, dust in Belgium. So if you're interested into dusts, you can select the relevant parameter. So here, dusts. This is like a sensitivity parameter. So if you want to get notified if there is, from the first level of alert, you can leave this how it is. And here you can define the area of interest. So I will draw a rectangle around Belgium, and this fills up this field. And you just create an alert, and you can see that, this alert appeared here in my collection of alerts. So I have 3 alerts, one over France, Norway, and now I have an alert over Belgium. So I think that was my overview of this service. And if you have any questions,
Thank you very much, Augustin. So we will not do the question now. Why? Is because online they can only have access to the question at the end of the session. So at the end of our session, all the experts will come back online to have a panel discussion. Thank you very much, Augustin. So now we are moving to Leonor Tarasson from NILU and Svetlana for their presentation.
Okay, thank you very much, Julie. And it's very good that now we have the presentation in place. What we are presenting is a bit of the policy application of these dust products. We have carried out, maybe you can put the next slide, Svetlana. Yeah, we have carried out with the help of Fairmode an evaluation of the use of CAMS products for a very particular policy application. And it is that under the directive, on the air quality directive, the EU allows member states to look at the origin of exceedances and deduct the contribution of natural dust to exceedances in certain areas if they can see that this is if they can prove that this exceedance is in fact due to Saharan dust. And the way to do that, it is made through a guidance document that was written in 2011. And it is very much based on in situ data. It doesn't have a reference yet to satellites, more than a very general one. And it doesn't have a reference, of course, to the CAMS products that came later on. So there is now a revision of this guidance going on. And we made an exercise that began last year in order to support the revision of this guidance and to advocate for the use of better information from satellites and better information from the CAMS services to identify that type of natural dust contribution to exceedances. We were very happy to count on this cooperation between CAMS and FAIRmode, and we had something like 14 countries interested in participating. We had 40 participants. ECMWF and WMO and EEA were following this exercise very closely. And the idea was really to see what type of products we have, how good the CAMS products can be used for this type of applications, identify some best practices, and then make sure that we can provide some feedback to the Commission when they are revising this guidance. So the result from this intercomparison, we've had three different interpretation meetings, and the results will be coming at the end of September, beginning of October, in the technical meeting of FAIRmode. So that's what we are aiming at. And it is on that context then that for policy applications, we really need to be very aware of what type of products CAMS is creating for dust. And I give the floor now to you, Svetlana, just to put it in the context of what have you been doing on the evaluation of the dust products.
Thank you, Eleanor. And
if you click,
I am clicking, but it's been like this for a while. Sorry. I start talking. Shall I continue clicking? Or what do you know?
Or now, click.
Yeah.
Because when you click this, the first part is an animation. We develop a viewer with all the different products. We develop, if you continue on that, click again, and it should come exactly. We made an extraction of the in situ data and the monitor and the modeling data at the same time, just for the users. So we understood what the users were needing, and we also provided them with information on the source allocation from this service of the policy service. If you click again, that comes in, and then it will be your slide. That's the point. Those 3 points is what we understood users needed. And now comes your slide.
Yeah, okay, sorry for that. We haven't practiced too much. One of the products, one of the policy products, it's the episode reports, which we are producing every year, up to 5. We never manage 5, but a number of it, and you can see a link where you can find. And some of those are due to the African dust intrusion. And just to say that even though I decided to select the cases to see where the models are differing and where the models are managing or not managing, rather not managing, to reproduce their observed dust events. So this is very optimistic presentation, because in order to now we have a goal to improve the CAMS models with respect to simulating dust. And to improve it, you have to know when it's not working and what's not working. Yeah, so that's why using the experience from those dust episodes and whatever I looked at, found interesting on the web, I tried to make some bullets about the episodes or cases which were more or less successful. For instance, the models they tend to quite accurately reproduce episodes closer to the major sources. Like we have dust intrusions from African desert, and in Mediterranean, most of the countries, they are, most of the cases, reproducing. They can overestimate, underestimate to some extent, but more or less fine. Except when the dust plumes are very, as I call them here, slim, and I'll show some examples. And then further away of the major sources, of course it's getting more difficult for the models to make accurate forecasts. And the most typical reason for those mismatches between the model or divergence and the mismatches with observations could be explained by inaccuracies in boundary conditions from the global model, and also from the wind-blown dust from this part of Northern Africa, which is within CAMS domain. And as I'll try to, if I have time, show it's not only amount of dust which is generated, but also where in this northern part of Africa it's generated, because there are different outflows, and depending on how winds are blowing from Africa, you can get very different results. Then how dust is described in the model, the size distribution, and it's more often it's deposited too fast. Sometimes it's deposited too low, but they tend to remove from the air too efficiently dust. Then the model plumes, sometimes they don't quite hit the site in right time or shift it in space, and also the height transport can be not corresponding with what's observed. I just go quickly through the examples. So I found this, there was an interesting case last year in January, and you see here 5 sites. I think this one, it's like Athens, and those ones, distance just like 10-20 kilometers. And the observations here, black lines, and you see at one side we have like 3 dust episodes. One side, one huge episode probably was here. And then 3 sites, there is no observed dust peaks at all. And those sites are very close to each other. So this is very challenging, you can understand, for the model to capture this. And then that was Athens region. And then Thessaloniki, that was different story. There was almost no dust. That's from 16th to 18th January last year. And then 18th lunchtime, it comes quite sharp episode, very thin and very just few hours. So those are, that's a challenging case. So what the model, how it looked, I show just 2 models here, because those are models involved in policy product simulations. Now we have also Chimera model. I'll show it later. So those forecasts, they start from 18th January, and left-hand side IMAP, right-hand side Lotus Eurus, and here it's yellow, it's dust contribution. So you see how much the models differ in the first day. The IMAP is giving dust here. Okay, I'm not going to describe. You just see this yellow dust here. And here it's observations with those dashed dotted, or there are many lines, because it's several stations within Athens. So it looks like here the model, or the IMAP model, was doing a bit better job compared to Lotus Eurus. But then if we look at Thessaloniki, then the picture is totally different. Then IMAP is giving dust, but it's too little and a little bit too late. So this big peak, it's not accounted for from the map. On the other hand, Lotus is doing fine job with this first peak, middle of 18th, but then the dust is disappearing somehow. Probably plume moved to the right, to the left, or yeah. And So here I just wrote the same as I said. It's not only the amount of dust, but where it's distributed in the Northern Africa, and then you have compare kind of meteorological synoptical maps with Africa to understand it. But I mean, this is just to illustrate quickly. Those are like 24, 26 hours maps, and EMAP Lotus, etc. You see time. And this Athens and Thessaloniki, I just rounded. And you can see how different, I'm not going to explain you see red, blue, etc. But you see quite different evolution of the dust plume. Then it comes new poof, and now it's surrounding this Peloponnese, and it's still very different between two models. And in the last one, now huge plume came in Lotus, while EMAP is less, yeah. But this is just to illustrate that in this case, Lotus also was using, it was last year, Lotus was using different boundary conditions, their own boundary conditions. So it's one boundary conditions and another what the model generated and where in Africa. Okay, just go further. And the second, now I think I have 2 slides. The second is illustration of what we manage better and what we manage worse. So closer to the African continent. That's some extract from the episode report, which is been finalized now. And during this period, it was 3 dust intrusions, and they were different, and they were very fantastic. So I recommend you to look up this report when it comes out. So Athens, EMAP, Lotus Eurus, and Chimere. And I think the models did very good job. Because here it's a comparison with observations. Lotus is simulating a little bit higher than the other 2 models and reproducing the exceedances. EMAP is simulating typically a little bit less dust and underestimate the number of exceedances in this case. And Chimere is, yeah, in between. But the models are, they look pretty similar, the results. And then we go, so that's, I think, 26, 27 something. Then in 29th, 30th March, there was new intrusion, and it came to like Nice, Marseille, to French Riviera. And there was a huge peak there, and then the plume started crossing South France and turning to Germany, and there was observed peaks of this. So this is example for Stuttgart. I don't know if you see those observations here. Yeah. So there was 2 days with like 70, 80 microgram per cubic meter, the daily average. But the models, they just, yeah, there's nothing in the models. And then there was a 3rd intrusion, and the models did a little bit better. I'm showing the last one. And this just compares 29th, 30th, 31st March. Here you see, yeah, 3 models. The plume is coming to the French Riviera, and those dots are observations. And you see high concentrations of PM. Those 2 models are giving a little bit less dust coming. But anyway, the day after, we see observed high PM. But it's blue. Blue, it's, yeah, nothing in the models. Yeah. And then the day after, that's another plume. And that was, that worked better, actually, the models, because this first plume, it came from, it was working like this to Poland, transported. But this was reproduced better. And the thing was, my last words, that in this day, this is dust modeled with the CAMS ensemble at 3-kilometer height. And you see there's pretty much dust here, but not on the surface. So I would say it's fascinating to study the cases when the models are not managing or differing. And I think it can give some clue what to improve and how to improve. And now Leonore is going to suggest something, I think.
Yes, exactly.
Thank you.
Because thank you, Svetlana. You are really talking about the fascination of us scientists when we see differences. But for policy users, they need guidance. They need to know what is best to use. When they are, in this case now in February, there was another episode where when we look at Madrid and Thessaloniki, it's very different results from the different models. And if you look at the regional dust product or the global dust product, they give different results. If you look at the background at the regional PM10 after the interim reanalysis, it seems to be in better agreement with what the global is giving in, and you need some guidance then to the users to what do they have to use and when and how. If you go to the next slide, it's a bit of the same situation. You've been talking already of the differences between Lotus Euros and IMEP. It's always a question we get from users because we have a lot of different products from the CAMS teams. And then the question is, and if you click there, is to understand the differences between the models. So if you click again, yes, thank you. One of the important parts here is to understand that Lotus Euros and EMEP use different boundary conditions, or they were using it at least in the 2022 and 2023 exercise that we are looking at. And they had both boundary conditions from the global to the regional, and we have also the bare soil conditions. But in addition, if you click again, the Lotus Euros is one of the few models in the ensemble. I think it's the only one, and the one that it is represented in the source allocation service. They have what we call not natural dust, but anthropogenic dust. They have agricultural activities and road resuspension model in their results. And this is very valuable because it shows the differences between the models. And through this exercise, we really came into the conclusion that it's better then to separate the anthropogenic and natural part of the dust so that the colleagues at Lotus Euros will separate this, and we will provide more clear data on what is natural dust and what can be the anthropogenic in the future. So this interpretation and guidance is an important part of what we are working on. If you continue, next click, what I wanted to show a bit is, well, how are we going? Oh, this is the old presentation. I'm really sorry, Augusta. I changed it. I don't know why this is there now. But what we wanted to show is that, yes, the chemical composition data maybe now in the first exercise were very different between the different models. We can make it more refined and better in the future by showing the natural and the anthropogenic contribution. And what is important is to give guidance to the users on how to use this information on the chemical composition, probably most as a qualitative adjustment on whether or not it's a dust episode, not necessarily for quantification. And then on the quantification, it's been interesting to see that in many cases, the interim reanalysis works better than the just forecast data from CAMS, and make also some recommendations on where to use and how to use combine the information between the regional interim reanalysis and the global reanalysis. In addition to that, next slide, please. In addition to that, what we've seen is that there are different approaches on how to do the deduction. Once you've identified the episode where CAMS data can be very interesting and very useful for the identification of an episode, then we need to see how do we quantify it to make a deduction. And we have some experience from the different countries here on using some approaches based on bias corrections. This is some part that we will put in, and then there are very interesting work done in Italy by Francesca Barnaba and colleagues that are working with the APASON methodology for investigating further the quantification of the deduction of natural dust. And they want to use more of the CAMS interim reanalysis data and combine it with LiDAR data. And that can be a very it's a very good exercise to continue seeing how to do this type of quantification of the natural dust contribution. The recommendation always is that we need still to go back and the alert system that Agustin was showing to us on the global system, looking at LiDAR and ceilometers. It's important. The AliceNet in Italy, where they have also this ceilometers information, it's relevant, but there's a lot of data in situ on particle number that can also be used there. So it's really a part that we need to continue working on. And that's the message we wanted to give. So that's the last slide. The message is really that for use in policy applications, model accuracy is really a very important topic. And it is a part where CAMS is continuously working to improve and to document what it is there. So we feel very confident on the robustness of the products that we have, but we need this detailed guidance on how to best use the different products when we are both identifying and quantifying the detection. So from the study that we've done during this 1.5 years, we want to really come in now with clear recommendations to how to do that. And we plan then to present this, as I said before, in fair mode and make sure that this can feed into the planned revision of the 2011 guidance document. What is also interesting is that the exercise also help us in CAMS to understand better what will we need to do to improve the service on dust, and maybe this thing of knowing what type of products to put in to get some of the information from the observations at the same time. This is a bit of ideas on how to improve a service on the dust viewer. It's also interesting to work with these anthropogenic and natural components, as I've mentioned before, and the fact that we can maybe think of ways of improving the regional IRA products when it is dust and we know it is there. So these are things that will always come back, and that we know how through these exercises and through this use in policy, it can make CAMS dust products of better quality for that type of applications. So thank you. That was all from our part.
So thank you very much to Leonor and Svetlana. So for the sake of time, I'm sorry we've gone through a lot of disturbance. We will not take any question for the moment. Our experts have a lot to say, so we'll ask the next one to be really concise and precise on what they say, because we're running out of time. So now we have finally Michael and Melanie to talk.
I hope we have Melanie to talk. Yes. So actually, in some ways, switching those presentations has been beneficial for me, because that previous talk identified some of the ways in which the services struggle to use the CAMS data and to see when it's a sort of good dust event or not, why there's differences between the models. And one of the differences they identified was the boundary conditions that are coming from the CAMS global model. And when I look here, as I'll be discussing, is how we use satellite observations within the CAMS global model to improve our forecasts, but also some of the difficulties we have because of limitations in the satellite observations. So to demonstrate this, I want to focus on one particular example. This is a Kalima event that happened between the 12th and the 16th of April this year. And it was an event where dust was blown from Africa across the Canary Isles up through the Atlantic and looped back in this plume across Europe. And I show here the CAMS global forecast for total aerosol optical depth, which was valid on the 14th of April. So aerosol optical depth is a measure of how much direct sunlight is prevented from reaching the surface because of aerosol particles in the atmosphere. So the more aerosol particles that you have in the atmosphere, the less sunlight can reach the ground and the higher the aerosol optical depth. And you can see that in this case, we believe this is a dust plume that's looping back across. We could track its progress in animations. We can see it starts in Africa and it comes back across Europe. And what we can do is we can look at the observations that are valid at the same time. So here I show the satellite AOD observations, so the same quantity validated for the same day that we used in the CAMS operational global system as part of our assimilation process or processing of the data. And what you can see is the observations clearly show this dust over Africa, and they also capture this plume that comes up over Europe. They don't capture all the plume. There's issues with clouds in the way, perhaps the misidentification of AOD in clouds and how the satellite instrument struggles with that. But they clearly capture some of that plume. And what the observations tell us is that actually that plume was higher than what we have in the model. And we can use that information within the CAMS global system to actually adjust our model, to realign it with reality, and therefore hopefully improve our forecast moving forward. So the final figure I show here shows the adjustment we made to our global model to make sure that the model itself is more in line with the aerosols that the observation sees. And if you look at that same circle, you can see that we're adding aerosol in where that plume is to make sure that the amount of aerosol and the location of the aerosol is improved in our forecast. So satellite observations are really valuable to us in the global system for making sure that we match reality and bringing us more in line with what the observations see. But this isn't quite the full story or the full picture. So AOD is a total column quantity. It tells us how much aerosol there is in a column of air in the atmosphere, but it doesn't tell us where in the atmosphere that observation is or what type of aerosol it is. So what we actually run in our model is not a total aerosol variable. How the wind affects the dust over Africa is very different to how the wind will affect the sea salt over the ocean, and we need to model those processes separately. So we don't have a total aerosol variable in a model, we have these individual types of aerosols. And so when we increment or adjust our model, what we actually have to adjust is the individual aerosol types. And the only information that we really have, because we don't get it from the observation, on how to adjust those individual types comes from the model itself. So for this example, we can look at the individual species, and what we see is that most of that plume comes from dust, as we would expect, but some of it is actually being modeled by sulfate. So when we come to use this information to change our adjustment of the individual species, we see that we adjust dust over Africa, but actually apply no adjustment over Europe. Instead, that adjustment mainly goes into sulfate. And we don't think it's sulfate. We can look at the regional model that people have previously talked about that perhaps captures dust a bit better in some situations, and there they think that this is a dust plume. We logically think it's a dust plume. And this is coming about because our total AOD observations don't give us information on the different types of aerosol that we can then plug into our model and adjust these species individually. So what are we doing to try and address this? Well, the observations we use at the moment of AOD come from the visible part of the spectrum, so they see most types of aerosol. We can also make observations of AOD from the infrared part of the spectrum. And when we do this, the AOD is mainly of coarse dust. So in a way, it's a coarse dust observation. And there's various different retrievals that exist that measure coarse dust AOD from the ARSI instrument aboard METOP. And two of these retrievals, from BERA and from ULB, are being worked on at EUMETSAT at the moment to be distributed in near real time. So in theory, we should be able to use these products within the CAMS system to increment and adjust our aerosol of dust rather than our total aerosol. And I show here just one example from some work I did last year. So it's a different situation. It's on the 22nd of February 2021. And this is the retrieval from BERA. And it just shows what they now believe is just coarse dust observations. And so we can plug these into our system and use them to adjust our coarse dust. And that's what I show here. So for this test case, the top row just shows the observations that we had available in our system at the time. So these are the AOD of total aerosol. And then the increment that we apply to dust in this case, and the final model state we have for dust. So this is all just showing the coarse dust field. And what you can see is that we do apply an increment to dust, but it's not particularly strong. And though we don't show it here, it's a similar situation. We apply a lot of that increment to sulfate. But if we then also include these YASI AOD observations of coarse dust and just increment our coarse dust, we apply a much stronger increment to dust, and therefore capture a much stronger plume in our final model state. So with these additional specific dust observations, the dust can be increased in the relevant locations, and this will improve the spurious increment to other species and also improve our dust forecast. And this is very important because it's this dust field that goes into the boundary conditions for the regional models and helps them then produce their accurate forecasts. So I just wanted to finish with some final comments, because what I show implies that perhaps our dust field isn't doing a great job. I do want to say I had to hunt through 8 different cases to find a case where it really demonstrated this issue. We generally do a very good job of capturing individual events in dust or in other species, but this is just an artifact that does appear sometimes and that we have a solution for that we hope to be able to investigate and to implement. The satellite observations and using them brings a huge benefit to our global system, and does generally bring the forecast more in line with reality. But there's these additional observations available to us, and how brilliant if we can use them to therefore improve our individual species and improve the situation for the regional forecasters, who I now will pass over to talk more about the issues they find from a regional perspective. Thank you.
I have to learn that as well. It's the green button, isn't it?
Oh, no.
Yes, okay. I have to push 5 times. Okay, so I'm Michael Gauss. I'm coordinating the evaluation of the regional CAMS models. And the first message I want to convey is thank you for your attention. Okay, sorry about that. So is that our thank you or the previous? That's my tomorrow's presentation. Okay, so I have to improvise. One important message is that the CAMS regional models are all very well-performing models. They meet the vast majority of the fair mode model quality indicators and objectives most of the time. And I will have time tomorrow morning to tell you more about the general model performance. And we actually showed you the first slide of my tomorrow's presentation. That was just meant as a teaser for tomorrow's presentation. Today, I focus on one problem we have. It's kind of one of the few exceptions where models still have a challenge, and one of them is dust episodes. And this is kind of relevant for this session. And this is, most of you are very well aware of this. It's the regional CAMS domain. And the challenge is that episodical dust events, of course, are not in our emission inventories. And what makes things worse, most of the major sources are outside the model domain. So it's very important to solve that problem either by improving the boundary conditions, because most of the dust has to come through the boundaries, the southern boundary of the regional models, or assimilate dust in one way or another. And yes, so in case I haven't mentioned it yet, regional models perform well. But I show you this example from the regional evaluation server. And you can go there yourself in case the plot don't show up. It's publicly available for everybody. And what I'm going to show you is an example for France. The very well-used dust episode we had in March, end of March. And there is a peak in the regional ensemble, but it's not anywhere near what was observed. And keep trying. Yeah, now it comes. So to the left, it's the forecast, and you see that famous peak here, and you see the peak of the ensemble. There is a peak, but admittedly not high enough. And this is the analysis, again, averaged over French stations, and you see the analysis, the assimilation of surface measurements helps, but it doesn't help enough.
And this is all the regional models, and I'm sorry you cannot see the colors very well, but I marked the observation here at 3 instances. And you see some of the models, they reproduce this first peak to some extent, but then they overestimate this secondary peak we had in early April. So there's a problem that has to be solved. It shows that many of the models, they had very well elevated PM concentrations aloft, but for some reason they have more PM in the free troposphere than and they underestimate PM at the surface during those episodes. And you can see this in this policy support episode report that was published recently. And as I said, the boundary condition is one thing to look at, and at the bottom you see the IFS model that we use as a boundary condition. That's dust at the southern boundary, and then just 3 examples of regional models and the ensemble, where you can see there's a difference. So there's still room for improvement, and using a boundary condition is not as trivial as it sounds. You really have to account for the different size bins, because the IFS model has different size bins than most regional models. So it's not trivial, but it's being looked at. And yeah, this is my final slide. As I said, boundary condition, I mentioned the size bins. I should also have mentioned the vertical resolution, which is different in IFS and the regional models. So this complicates the issue a little bit. And then another pathway we are looking at is assimilation of satellite data, and Melanie has explained that in all possible details, so I will not dwell more into this, but yeah, I will just tell you that regional models are looking into these possibilities, and this might improve the situation in the future, even for Saharan dust episodes. So now I can really say thank you, I think. Thank you.
Thank you, Michael and Melanie. It was really struggling. We need to be patient, but we are making there, so keep calm. Everything is happening. So now we will move to another presentation. We have 2 more, and then you will smile for the photo and then have a coffee to relax. So we need to move now to the global and regional products to support national local system, including boundary condition. So we have 2 speakers, from IGEO, Samuel Remy, and from INERIS, Augustin Colette. Please, the floor is yours.
Okay. Is it working? Yeah, it's working. Okay, well, good afternoon, and thank you, Julie. So I'm Samuel Remy, and I'm co-leading with Vincent Rion on the development of a global system. So if you see something wrong or right, I mean, I'm the person you can come to complain to, or ECMWF as well, of course. So Augustin and me are going to talk about the products that are produced by global and regional models, and also about modeling efforts, of course, that we try to do in order to improve those products, and also about the evaluation procedures that we apply to see that we do more or less okay or not. Okay, so dust storm is, of course, I mean, dust is a high value product. I mean, we put a lot of effort to try to improve our forecasting here. I mean, those are just a few examples around the globe of high impact dust events. There was in particular this dust storm in March 2022, which was really quite an exceptional event. And in terms of impacts, there's many impacts, of course, of different, I'm just here showing a non-exhaustive list, but solar energy, of course, high quality, that's an obvious candidate. The radiative impact on the quality of meteorological forecasts, which can be impacted by dust. Transport of nutrients from dust, like iron, phosphorus, etc., is not always obvious, but this is quite a major impact. Also, the impact on ocean biogeochemistry, and also the impact of dust on remote sensing through actually changes in ocean color and aviation. There's, for example, this recent paper about the impact of dust on aircraft engine using CAMS data. So we do try to provide products to address this kind of problematic. And the products that we provide in terms of global, Augustin will present the regional products afterwards. So in terms of the global, is of course dust optical depth, AOD was explained by Emil, so this is basically the equivalent, but only for dust. We provide the 3D mass mixing ratios of dust for each of the 3 beams, which is used actually as an input from the regional models for boundary conditions. And we provide, of course, emissions burden deposition for each bin. So this can be interesting, of course, if you want to study the life cycle, emissions, deposition, sedimentation, etc. We have other products that include some influence from dust, but not only from dust, but for example, this 3D extinction coefficient, which can be compared to the products that Vasilis showed, for example, and radiation fluxes, which include quite a signal from dust. So this is shown here, an example of dust AOD from the last weekend, where there was a small dust event over like Spain and southern France, simulated by the global, and which actually happened also. So in terms of modeling of dust emissions in the global system, this is quite a complex parameterization. This is basically, we're trying to represent these siltation and sandblasting processes, which depend a lot on meteorological, so wind and friction velocity, which depends itself on wind, surface specific, soil wetness, and also the fraction of soil that is made of silt, sand, and clay, which is not something that is easy to acquire globally. We use parameters from 95. We also tried some more recent ones with some, in 2011, like Koki-Kantal, and this quite famous size distribution that is used by many models. But this is very challenging, of course, because we have a lot of uncertainty on many inputs. Typically, the soil topology, for example, the amount of sand in each tile of a soil is not so well known. And of course, to represent such small-scale processes, which occur in reality at the meter or 10-meter scale in a 40 times 40 kilometer grid cell, is also quite a challenge. So for example, here, just to emphasize this challenge, we represent dust in 3 size bins, which are currently assumed spherical in Cyclo 48R1. We're working on that actually to do something a bit better. This is showing basically the ideal dust that we have in the global model as compared to real dust on the left-hand side. You can see, of course, how challenging it is to represent real-life dust versus the simulated dust. But still, we're working to try to get closer to reality. And we put a lot of effort to improve our global model and at each cycle upgrade. So this is showing basically the timeline of the past and future global model upgrades. Cycle 48R1 appears here in 2023. It was on 27th of June. And just to show, I'm not going to go through all of that, but all of the developments that were carried out and implemented that aim to improve the dust modeling. In terms of future, in Cycle 49R1, which will be used R1, R2 for the CAMS analysis, we also implemented this dust as sphericity. So dust won't be represented as spheres anymore, but rather as spheroids, which is closer to reality. And in Cycle 50R1, we hope also to implement an increase in the number of dust bins from 3 to 6, which will allow a better representation of the size distribution of dust, and hence of sedimentation, and etc. We have also several projects, Horizon Europe project, that aim to support CAMS activities, which will be mentioned in more detail tomorrow. But in particular, the camera projects, the CAMS aerosol advancement, in which we are going to work quite a lot on dust modeling. We'll try to develop some best estimates of global dust emissions with the IFS, online and offline. We also try to apply machine learning techniques for dust emissions, which is something that's rather new. Direct estimation of infrared radiances, which is a little bit in the line of what Mel showed, but using the direct, let's say, output from satellite, from remote sensing. We're going to work on high latitude dust, actually, and that's why, I was particularly interested to exchange with Pavla on this subject, on road dust, and of course try to see how we can help in terms of boundary conditions between global and regional, because as Michael said, this is quite a subject. And of course, the Cameo project, which is already ongoing for 1.5 years, with the estimation of dust AOD from Yazi, that's Mel's work and that you showed already. And of course, we also try to evaluate dust deposition, so simulated dust deposition against some products that are derived from remote sensing. This is shown here. We have, so through a mass balance algorithm, we have a MODIS-derived dust deposition and also some climatological observations shown basically here in circles, as compared to our simulated climatological dust deposition, and showing that we are not too far off, probably a little bit too low in the Western Atlantic, but that allows to a comparison of dust deposition, which is not so easy because very little observations are available. And also ideas to try to evaluate the uncertainties of global dust products using an ensemblist approach to say how much we are sure or unsure of the product that we are providing to you. So I think that's it for me. Hand over to Augustin.
Thank you, Sam. I continue the presentation with a few highlights on the various products we are producing at the regional scale. So I start with this regional production, so CAMS 240, the 11-member ensemble, and just to recap the fact that we have two different entries to get the products, either through the online viewer, you go directly to the website, or you can get the numerical data on the ADS. And you don't necessarily have the same thing on each of those entries. So in terms of production, we have one tracer for dust, which is actually in the size bin PM10. It's produced in the near real-time forecast since June 2019, and since then we've been catching up in also introducing it in the various reanalysis products. So for the validated reanalysis, it's being produced since the year 2018, and it's now available in the ADS. And for the interim reanalysis that go further a bit in time, they include more recent years. We include the year 2020-23. 2022, 2023 in the ADS. Again, if you are interested to look at the various altitude of the dust plumes, you may want to look in different places. For the interactive viewer, you have a few of these altitude slices, but if you're looking for a higher resolution in the vertical, the ADS is really the place to go. So there are a number of things we provide, there are a number of things we don't provide, and we are considering to include in the future. And so far in the discussion we had within the service, we identified the following. Typically, total AOD is one of the key products you're looking at when you look at the global forecast, and it's not produced in the regional system. So that would be interesting to have in terms of comparison. Likewise, we don't provide any information on deposition, and we could also model direct diagnostics of surface extinction, which is clearly a very interesting diagnostic for visibility and airport operations. We also identify the point on the granulometry. As said, we only deliver PM10, the dust in PM10 fraction, and it would be interesting to add more bins for the further follow-up users, and especially those that are using the regional models to drive the boundary condition of the national systems. And then the last point was somehow a bit touched upon by Leonor and Svetlana in their presentation. The fact that when we provide a dust diagnostic, we don't exactly say if the dust is coming from the boundary conditions, so typically Saharan dust, or if it's in-domain resuspension, or it could also be road dust, which is very important in Northern Europe, or even induced in relation to agricultural activities. So that's it for the various products of the regional production. Then there are the policy products, CAMS 270Y. So here the entry is slightly different. We try to make it a bit more interactive, user-friendly for policy users. So we have a number of tools that are interactive on the website, for which we provide either the chemical composition or the geographic origin. So through the geographic origin, we tag the natural sources and typically dust. And that's available in 3 numerical models. That's available for the daily forecast, but there is also an entry to look at the yearly report. And that's the snapshot I provided on the screen views here to highlight that if you select a city, you can know the relative contribution, the relative importance of dust on PM10 overall for that city. That's available, again, either through the interactive setup, but also as numerical data. And we all know that the ADS is great when you want to access the data. We also face the issue that some of the policy users are not so comfortable with this type of data. That's why we also provide directly the JSON that they can download on the website. So again, we try to identify what we could do more. We know that there are requests for us to produce custom maps, not only going 1 month back in time, but further, and also extraction of the CAMS product at IONET stations, and that's in relation with the exceedance discounting that Leonor mentioned. And the last 2 points, I don't need to go further because Svetlana has explained quite in detail what we produce in our episode report. There is also the annual report, which is forthcoming for 2023. And very important is this type of joint exercise that were conducted, led by Leonor in collaboration with Fairmode on the use of the policy products for the reporting of individual countries. Now I want to open a bit what is in the engine. And I'm sorry for the table, which is quite busy, but and I'm not going to discuss that in length, but I want also to provide some insight in the complexity of this type of system. At the end, we are using 11 models, and there is this one global model, the first one on the left-hand side, IFS. And of course, there is a reason why we produce these 11 models. And that reason is actually synthesized on that table. There is really diversity and a value in the physical diversity that is implemented in the various models. You can look at the various references that are used to model dust in the domain in the regional systems, and you will realize that some of them are common, but it's also very valuable to have different models implementing different strategies. And the lower 3 lines are actually a point that was raised already by Michael, the fact that when you nest the regional model in the global system, you may actually make some choices in the way you transfer the size bins from IFS to the regional system. And that is really a very important point and very interesting way to work with the global modeling colleagues in the future. So this matching of IFS boundary condition in the regional system is really sensitive for us, because each time there is an upgrade in the IFS system, it will have direct consequences for the skill of the regional system. So that's why we've been discussing for a while, and we know that there is really a need to have this 1-year rerun to anticipate the impact and be able to check if the model runs appropriately. Then there is the approach of matching the size bins. It's not trivial, like Michael said, but it can be done, and the most sensible approach is actually geometrical. You assume some distribution in the modes, and you apply that to match your regional model. That's what is done for all the models, and I must say that the consistency has really improved in the past couple of years, because we've been reviewing that in collaboration with individual people. But then there are alternate approaches that we are not using at the moment, and we think would be interesting to promote in the future. The fact that we could actually normalize the dust distribution in the regional model to that of the global model. For example, if you can run a climatology with your regional model. If you cannot do that, you can also do a scaling according to the deposition velocities of the different size bins. And if you do that, you would have a much more robust setup to be less sensitive to the changes when the global system is upgraded. I'm finishing with a couple of slides on evaluation, and I will again be very fast because Michael went through that, but it's really important that we evaluate carefully what we do. Leonor said that we need accurate models for the policy use. I would say that besides accuracy is the ideal goal. If we are not accurate, if the models are not perfect, at least we are able to we need to be able to document the uncertainties. So we have really a wealth of information in terms of various diagnostics to assess the quality of the model, but we have to acknowledge the fact that at the moment it's really related to PM10, and we're not able to evaluate on a routine basis really the dust fraction. So this is something we really need to work on to convince the policy users in particular that the products are robust enough. There are different ways to do that. One of them is actually to compare multimodal ensemble, just an illustration provided by Sam, the fact that CAMS is one of those models that is used in the ensemble of the Sand and the Storm watch organized under WMO. But we have similar in multimodal comparison when we look at the regional forecast in the CAMS ensemble. And then there are also different initiatives. Some of them on the right-hand side were already mentioned by Leonor, and I wanted to remind what was done as part of the CAMS 61 project a couple of years back, and I think this work was actually performed at BSc, when they were actually doing an assessment of the PM2.5 to PM10 ratio. And that's something that can be done relatively easily, even on near real time, and can provide very good information on the skill of the model to actually model this cost fraction and relate it to performances of dust. So I'm finishing with this overview that we try to combine with Samuel on the fact that there are different strategies to evaluate the dust fraction, and they can rely either on ground observation, remote sensing, fusion products, or even just models with this type of multimodal intercomparison. We know that we are already using a number of those, and through the examples you've seen this afternoon, this has been shown in different ways. It's largely used for the development, but I think now it's also time to engage in using that for the near real-time evaluation, because we need this quality control if we want the users to actually have trust in the product, especially for the policy applications. Thank you.
Thank you very much, Samuel and Augustin. So we will finish now with our last presentation for this session with an application for the energy sector presented by DLR. Marion, the floor is yours.
Thank you very much. And let me talk a bit about my understanding of how we need the dust episodes in the energy sector. Great. You may know me as the one responsible for the solar radiation service inside CAMS. My main work is scientist at the DLR Institute for Networked Energy Systems. And we also have colleagues involved inside the Copernicus environment here from the Institute of Solar Research. So our main business is, I've just copied from our webpage the challenges for the whole institute. Strategies for sustainable energy systems, market design and business cases, balancing energy supply and demand, that I want to talk about more, grid management, electricity, that I also want to talk about. So you see, I'm trying to give you what I learned with discussing with actors from here, and then we have the colleagues from the Solar Research Institute mainly on the qualification and bringing metrological information into the engineering world of solar energy industries, okay? So that's the background of this talk. So, talking about radiation, dust, of course, is, there's extinction, we have reduction, it scatters, it absorbs, we all know that. So practically, this MODIS image, if we don't see the surface, the solar energy system don't see the sun. That's the other way around. On the right-hand side, more in numbers, irradiance, extinction for desert-type aerosol, 30, 40, 50% in direct radiation is very easily, 15, 20% also in global radiation, what the photovoltaic systems need. So that, of course, we profit from all accuracy improvements in total aerosol optical depths. And dust, of course, is in many solar energy regions of special interest. But there's much more than just having that extinction. This is an image actually from Sandia National Lab in the US. It tells you the impact, the natural impacts on PV production. And you see number 6 is the solar input. They talk much more about suspended atmospheric particulates and the deposition and the soiling on the surfaces. And all that together with radiation is then important. And what is really the issue? The dust, once it's there and deposition took place, it remains, it sticks. Depending on the weather conditions, it can stick for days or weeks, or it's just blown or washed away. So that means then we do a good radiation forecast. We grab the aerosol alert service, the event is gone. But in practice, for solar production, the dust remains. So all our irradiance forecasts, if we turn that into a PV or solar production forecast, they remain wrong because we do wrong assumptions on the dirty solar panels, or at least we are on the risk of that. So it's much more complicated than just grabbing radiation. Just to give you examples, this is a dirty solar panel. This is a very dirty solar panel. What you need is kind of modeling what's happening at sedimentation, the wind is blowing on that, and what is the situation, what sticks. And if you have these kind of technologies, concentrating technologies, you can easily imagine if you have additional scatterers here, the radiation, which seems to be, should be at the mirror here, concentrated to the mean, it will go somewhere else. It will never concentrate. That means the impact on this kind of technology is even a factor of 10 times higher than on photovoltaic panels. Boils is simply soiling. So now, let's imagine we have many, many solar systems around. We had such an event. The one who's really responsible for security of our energy supply is not the owner of the PV plant. That's a grid operator. And their job is a permanent balancing of demand and supply. What is important to realize is in their control zone. One thing is to balance all the time, but the other thing is to balance in a large area. That's their job. For example, company Tenet has a large, in Germany we are a bit specific, we have 4. In most countries we have 1 TSO. So this institution, making sure that electricity supply works, wants to have a good solar production forecast for the control zone area. That means it's a large-scale area. That means, on the other hand, such a situation, it's cloudy. If we do validation versus point observations, we get incredible bad solar radiation forecasts here, because we're always wrong. The cloud is always at the wrong place. It's very hard to predict. But the many, many PV systems below, they average out. So the total forecast error is much less. But if we have cases which have a large geographical scale, a large error at many places in the same direction, or we have a smaller area but with very high amplitude errors, these are the cases the grid operators are interested. And, well, a dust outbreak is exactly that case. Small error in radiation, most times, but happening over large areas that we have seen in the alert service. The other case which may happen is a phase error, for example, atmospheric low covering over the North Sea. It's a region only, but very many installations there. So always multiply with the number of installations. Yeah, that's important here. We have seen studies in 2017, I know of 2 studies, one here from the Spanish Met Service using at that time, you still see MEC in this paper here, yeah? So the precursor of CAMS. And there you clearly see an improvement. The red line is the observation, and if you add the aerosols at that time from the MEC time, it gets much better and fitting better to the observation. In the case here, direct radiation in Maspalomas. Or this is an example done with not the CAMS world, this Icon Art model in 2017 on a case where we had a big dust outbreak and a big forecast error on solar production, yeah, and that could then be filled by modeling the aerosol. So that has been shown that this is an important step to go. And now it's a bit the question, how is CAMS doing? Okay. So we regularly, as part of CAMS, we evaluate these forecasts. This is hourly day-ahead forecast here. What we see typically in desert regions, that's a typical pattern improvement what we see. This is histograms over deviations. On the left-hand side, global radiation. On the right-hand side, direct radiation. And you see a certain bias. The whole distribution of the red curve turns towards more to the zero line, to the green curve, if we have the aerosols modeled properly as we do here in CAMS. And we see this impact as soon as we have radiation forecasts assessed in desert regions with not too many clouds. We're not doing better in the cloudy areas, but we're certainly doing better as soon as we are in such desert regions, and these are typically solar energy regions. So this is really a big asset for the solar community here. Now, we have seen this 9th of April. I also was tempted to use that one. I have to admit by chance it's the same, but of course it's something we have all in our mind. Yeah, copying the image from the alert service. Yeah, we have seen already a field coming across involved in an atmospheric low system, visible also on the satellite image here. Coming across, this is a 12 UTC. Now in eastern Germany. So in the morning, it was somewhere crossing Germany. At nighttime, it's okay with solar energy, then it's zero, forecasted to zero. That's not a big error. But of course, at noon, it was relevant. This is the actual taking from the energy charts. That's a portal which gets the actual production data from our transparency platforms, from the grid operators. And here you see the same day. What you actually see is in yellow the actual production. You see the day-ahead forecast in blue, and it may be hard to see. It's really up here. Then you see the intraday update, so that was produced in the morning. That's important because we have an intraday market where you could correct, but that was also very off. And then they do an online monitoring of what they really see in the network, and that's what they plan for the next 15 or 30 minutes or the hour. And there they got closer to the reality. Yeah? So this is roughly 2 gigawatt wrong compared to the day-ahead forecast. Yeah? So we are obviously not really integrating this kind of events up to now. Now, look a bit further, now widening a bit our view towards the whole renewables. Solar is one thing. And do markets react on that? I would like to go a bit deeper into that. That example, you still have the iconized image on the case. Remember, we had an atmospheric low which transported the dust towards, now our case here in Germany, and that we also had solar production forecast error, 2 gigawatts. This plot here shows you the renewable energy production. What is reddish is solar, and what is greenish is wind. So an atmospheric low has lots of dust, but also lots of wind. So a strong increase in wind energy production at the same time. So this is the same plot as the yellow one, but for wind energy. And that is the green is the wind. Here we always look at that time. Yeah, that's the wind amount which we actually got at wind energy. You have the day-ahead forecast in blue. You have the intraday forecast coming in the morning, and then you have the estimate what the grid operators are doing with actual measurements. And on the first glance, you could say, well, that's good, isn't it? The event is met. As a grid operator, I tell you, this is awful. If you go from here to here, you have 5, 6, 7 gigawatts error. And grid operator reads that plot not at the area under the curve, what we typically do. They read always the vertical line, and if they disagree, that's the problem. So we had, at the same time, an even larger forecast error in wind energy. Okay? So what happens then? Now I get to a very busy part. This is the same timeline. This is the day, and this is what we call redispatch. Redispatch is if the grid operator realizes, oops, my planning from yesterday was wrong. Now we have to reshuffle our activities. We have to make sure that we had enough production where we need it, and all the different colors means the different TSOs in Germany, which are now rearranging their grid, and where the power flow really is. That's what the different colors is. And what you see is at noon, there's a bit of activity. Yeah, we had this solar noon error. But then with the activities and the wind error forecast, yeah, that and also in the day before, there we see the dispatch activity coming. And if we look at the other thing, what we have below here is the prices. And let me try this one now, I'm not sure if you see that. On the evening before, we had a very strong increase in intraday prices. But that was not the dust event, that was the, sorry, I don't see it here. That was just the strong forecast error in wind. Yeah? So we have two different ways to react. One is the grid operator. They have to react, and there you see in the redispatch needs, which I obviously had, you see a reaction, while on the prices on the market you don't see. And my interpretation of that is if there's no one who has to refill a forecast error by buying. And remember, with solar, we don't have big power plants nowadays. We have many small systems, and private owners are not obliged to fulfill anything, yeah, like a power plant operator. So that means there's no one asking on the market for an extra, yeah? Or the information came too late. That can be the other big explanation. In future, we are now seeing 150 megawatt PV power plants coming up, or 600 megawatt PV power plants. They will really have to react here and create then price peaks. That's the expectation, because we see something happened, yeah, that we see in the redispatch. Okay, but it's not just the dust or the solar. Always think solar and wind together, okay? So let's summarize that. If we look for important forecast errors for grid operations, we need to have spatially correlated forecast errors. Yeah? Just forecast errors is not bad, but if they're spatially correlated, that's important. So really important for our metrics, how we measure forecast accuracy. Have this control zone concept in mind, large areas. Dust outbreaks therefore are relevant. We see improvements in CAMS. Have in mind the soiling issue. Same for pollen, snow, and so it's more truthful than just dust. Yeah? And yeah, we see impact, and I guess that we see that on market prices as well, as soon as we have large-scale PV power plants which are currently constructed. Yeah, that's what I grabbed from the communication and trying to transport our knowledge to those people all the time. And yeah, I thought it may be nice to summarize that for this case here and how it looked like on our German markets. Okay, I think that is my thank you. And may I ask a thank you to the technical team now, solved all that, but I leave that to you to ask for another clapping for that. I'm happy it worked for me.
Thank you very much, Marion. Indeed, so it was a wonderful presentation. It was a fresh light on the dust and not only events. So I think everybody has appreciated. I will want now ask you to finish this session. Unfortunately, we don't have any more time for Q&A, and I will ask you to de-dust you. You will have to lift up and have a big smile on your face, because we're now doing the group picture before you can go to have a nice coffee break. Thank you very much. And before you stay on your spot, you stand up, and as you're standing up, you get a good round of applause for everybody who has helped to fix every technical issues. Lift up.
I hope you had a nice coffee. Before we start with this, I would like to make an announcement, because tonight we also celebrate something else. We will celebrate 10 years of Copernicus at ECMWF. This won't take place here. It will take place in another venue, the Bellevue Museum. It's about 20 minutes walk, and we will start at 7 o'clock. But it also comes with another treat, that you can visit the museum. So I would advise that immediately after we finish here, you go immediately to the museum. You can do a small tour, you learn something, and then at 7 o'clock there will be the talks and there will be a cocktail. So that's an announcement. I hope you will all enjoy tonight. But let's now move to users. It has been the red line throughout the whole day. In many aspects you have seen it. And I would like to give the floor to a set of speakers who have been carrying user engagement throughout different activities. My first speaker to elaborate what we have been doing is Thomas Pop, and he will elaborate on what we have been doing yesterday during the Belgian user uptake event. So Thomas, the floor is yours.
Thank you, Stein. Can you hear me? Yes. So, my name is Thomas Pop. I work with DLR, and I'm leading the contract on CAMS user intelligence. And as part of this contract, we do user days, like we did yesterday for the Belgian community. So together with the local co-organizers, Lisa Blith, Elke Trimpeneers, and Jan Verbesselt, and with my team, we organized this user event. And what we usually do is what we call a user interaction session. So this is more than just a workshop. It combines collaboration with the National User Forum, a small number of interviews, then a workshop, and finally a workshop meeting to take stock of further actions in the country, in the CAMS National Collaboration Program, or for the CAMS services. And we do this based on strategic criteria to choose the country. We do this with a structured form for the interviews, with all the communication support that we can get from CAMS. And finally, we write a report. All these reports are published on the CAMS website for each of those user interaction sessions. You see here on the right side a map of those user workshops that have been held since 2009 in the preparatory project, MEC, Promote, and then in CAMS. And the lower list in yellow, this is those combining this interview phase with the workshop, these user interaction sessions. Yes, for Belgium, we did 4 interviews with very complementary different use cases. The interview partners were the Environmental Agency, the Institute for Space Aeronomy, the Flemish Institute for Technological Research, and the company Luminous. And their use cases go about air quality, as in every country, first forecasting and alerts based on expert opinion, then development of future health indicator, satellite validation, campaign planning with using machine learning, and finally air quality again, but in this case using the CAMS tools for scenario analysis and for sector regional analysis. And the fourth use case, different application domain, electricity management for a distribution system operator, and of course the CAMS relevant information is the solar irradiance. And you see in the last column on the right the products of CAMS which are of interest or of relevance for those use cases, which are the air quality regional ensemble, but also the global atmospheric composition model, in particular the 3D information, then again the regional analysis and the emission data, and the solar irradiance products. Based on these interviews, we had a first interaction, and then we had talks related to those interviews in the workshop. But already from the interviews, we could extract some interesting findings, like collaboration of an environmental agency and a downstream developer. like the statement, CAMS is providing valuable additional information, or new user requirements. We heard also in the last session, more guidance on the policy products is needed. The value of the vertical profiles to improve a satellite product on NO2. Several applications like health, like validation, like scenario analysis have a limitation with the 10-kilometer resolution that is provided from CAMS. Machine learning needs long data records. And then I move on. After these interviews, we do try to grasp the main features of the use cases in what we call value chains, which try to put together the critical elements and the actors that are needed to achieve this use case. So you see here the Belgian air pollution forecast, the working system on the left side, their own forecasting system based on Chimera, down to regional forecast maps, and then in the key you have expert judgment, which uses their own system, which uses other forecasts, but also comes as valuable additional model. And this is then the basis to decide whether an alert needs to be issued to regional authorities or to the citizens. The plan in the National Collaboration Program is to improve this by directly using the CAMS system from assimilating global long-range transport information down to the European ensemble into this forecasting system with different techniques, and also to use further the source apportionment tool, but here again this point on more guidance needed to explain contradictions between different models was raised. The other value chain for Belgian interviews that we extracted was on this electricity management, so a completely different topic. And here, the setup of this company is fully operational. They use the IFS solar radiation with machine learning algorithmics, and then they additionally use the CAMS solar radiation to adjust this IFS solar radiation to achieve an improvement. They talked about 4%, which is really relevant in this community. And this is really fully operational over Belgium. They are satisfied with the data provision, also with the limitations of the CAMS service. And they also reported that CAMS pollen and aerosol information is relevant for them to plan cleaning filters of gas plants. So that's a completely different element of an energy supply chain. Yes, then the workshop with 43 people, we had further discussions on those use cases, gave some information. We saw quite a very high level of interaction yesterday. This workshop size seems to be the best size for really getting the dialogue and not only presentations. We had a number of useful suggestions. I will go on them in the next slide. We really saw different use cases. They are not simple, just downloading, visualizing. They are complex use cases, so you need some expertise, but you can achieve meaningful output. And yeah, we also see machine learning is more prominent in such use cases. Yes, and there was also already first considerations by the national co-organizers about the next user workshop in Belgium, which they will do in the NCP to follow up, so that this is not a one-shot activity that we did yesterday. And yes, we closed with an interactive session. We had only 20 minutes. In 3 groups, we worked on 3 of those use cases, and I don't expect you to read this. I will give you a few hints here to conclude my talk. So it was amazing how much feedback and ideas we got in these 20 minutes. So talking about electricity. There was not much written on electricity. Yeah, here we are. Because overall, they were satisfied. But the game changer for further improvement would be solar radiation forecasts. This was the clear requirement raised. Talking about air quality tools, there was a discussion about the scale, 10 kilometer, or how much finer is it needed. There was a discussion how much CAMS can refine the tools to split the sectors in sub-parts to provide more detail so that the playing around by the users for policy purposes makes more sense or gives more relevant information. There is a requirement not only for cities but for gridded, the whole area covering this source apportionment tools. And this needs to be discussed and analyzed, of course, in terms of effort that is required. And in terms of air quality information, there was, it's also even difficult for me to read now, there was a wealth of aspects that there are other sectors or other elements which are not so much in the focus so far of the discussions, like dust and heavy metals or industrial mining. There was also a discussion about downstream air quality information for industries, and the ammonia problem was discussed, pollen was discussed, so we need to analyze this further. But you see there was really ideas and requirements and suggestions in the room, and from all these user workshops we pulled this together, and I will have another presentation at the end of this session beyond the Belgian part and will summarize this to you. Thank you for this first part.
Thanks a lot, Thomas. Are there some questions for Thomas? Guy has a question.
I'm back.
So this is a pretty difficult exercise what you do, so congratulations. But I would like to know how you pick your stakeholders. Because you showed a list of stakeholders who were, some of them at least, contributors to CAMS. Now, the stakeholders might be in different areas. This morning we talked about health and agriculture, electricity is another one. So how do you find them, and how do you make sure they represent a large fraction of the people interested?
Guy, this is absolutely a question to one of the challenging points. You're fully right. So the first part of the answer is it's essential, this we have learned over the many years of doing user workshops, to collaborate with the National User Forum, because they usually know at least a fraction of the relevant stakeholders or core users that are willing also to contribute in such a discussion. This is the first part. The second part, we also see limitations. Even those national coordinators of a user forum or of the NCP contribution of the country, they have blind spots. They don't know certain application domains. And then it's really very, very challenging. Either we know someone by our networks or my team, or by the invitation which is published through the CAMS website, through the national network, we get hold of new users, but often we have the feeling we missed some, because there is this challenge that is still open. Yeah.
Thank you, Guy. Am I connected? Yeah. It's something which we continue to work on, not only Thomas, of course, and the team behind Thomas, but also us at ECMWF. And for example, you had Luminous, who's a big energy company, as you know, and that was fresh. So Luminous was not known to us. But often it's incremental steps. Yeah. And that's why user engagement often needs to be driven by a team who builds this knowledge. And you can have this in systems, you can have a user requirement management system, but the knowledge often sits in the team. And that's one of the strongholds of CAMS. We have a dedicated team who's doing this for many, many years.
And the pickup in the NCP and with the National User Forum to follow up for a next user workshop. This is also important. Yeah. Okay.
Okay, if there are no other questions, I would like to move now to the next session, which will be given by my colleague Cristina Nanasso, and she will give an update on the very successful CAMS National Collaboration Program forum, which we had yesterday. I pronounced it wrongly, but you will correct. Cristina.
Thank you. So good afternoon to everybody. Yes, my name is Cristina Nanasso. I am the coordinator of the Copernicus National Collaboration Programs. Today I am with CAMS and also yesterday with a lot of you. And we also start with the C3S with a similar approach. I really like to introduce the program starting with this roadmap. So for us it's very important to start with the date that was when we presented for the first time the National Collaboration Program to the Copernicus User Forum. After less than 1 year, we signed the first contract with the first country. And then everything started, let's say. Last year, 1 year ago, during the General Assembly in Spain, we had a side event and we had the first Atmosphere User Forum. For us, this is becoming really a key element of the National Collaboration Program. We want really continue with this Atmosphere User Forum and with creating these a community of experts, and you met already a lot of them today, but in particular yesterday during the third Atmosphere User Forum that took place yesterday afternoon. A lot of people attended, much more than expected, but this is really a good news because it means that not only the NCP contractor, but also, let's say, the NCP friends want to listen to us and want to understand what we are doing. We, at the beginning of 2024, we closed what we call the first phase of the NCP that covered 2 years, 2022 and 2023. And in the figure, very colored figure, the bottom part of the slide, you can see which is the status of the different country participation. So far, at the end of this first phase, we have 17 plus 1, meaning that the last one is joining, let's say, in the next few days to close the negotiation. So we have 18 contracts ongoing with 18 countries. Some of them already closed the first phase of their contract, so the first contract, and you see them in a light blue, let's say. So Denmark, Italy, and France, and soon also Germany will be part of this gray part, but we already start with them the negotiation for the next phase. And then a lot of other countries are joining. We respect their timeline and their willingness to participate to the program because we really understand that is something where there is a lot of effort to put in, and not only on the content per se, but really on what we call the engagement with the national user. And this is for us an important aspect. We are in contact with all the countries, so 30 countries, 27 plus Iceland, Norway, and UK. All of them are interested, and sooner or later we hope to have them on board. Phase 1 and Phase 2. The key word in these two phases is really continuation. So there are some common aspects on these two phases. The modular approach, we give the countries the possibility to select the topics and then the work packages in which they are interested, apart from communication that is the only one that is really mandatory. And we really acknowledge the importance of having put this, let's say, this push on the communication part. We created this Atmosphere User Forum as a community of experts that discuss not only with us, with the ECMWF, but among the country. And I think that this is really another value of the program. We have a CAMS website where all the countries contributed with their input. In the first phase, we had 7 thematic work packages with a fixed duration of the contract of 18 months and with a fixed budget. In this second phase, we added a new work package asking to the country to develop an end-to-end demonstrator for two national communities that for us are quite important, and these communities are around health and around energy, because as you know, we have these two hubs to develop at ECMWF. In this case, the duration of the contract is variable, so independently from the starting date, all the contracts will end at the end of 2027, and consequently, also the budget is different. Okay. Now I have two slides on the, for us, let's say, the most important achievement at the end of this first phase. As I already said, but for me it's very important to remark this aspect, to have created these NCP communities. A lot of these people are here today, and it was also here yesterday during the Atmosphere User Forum, and a lot of them are also connected online. One of the, from my perspective, one of the most interesting aspects is really this excellent advancement in communication activity at national level in their own language. And you can see here some interesting web page or a screenshot written in a language that I cannot read, but indeed it's very interesting to have all of them together. Excellent exchange of experiences among a country. In this meeting, the forum, but also the technical meeting that we are having with all of them, it's very important that there is this continuous exchange with the country. So not only with us as ECMWF, but there are a lot of bilateral discussion within the country. Another aspect that we really appreciate is the frequent requests that we receive to attend national events. And thank you again for having invited us to some of your national events. Again, we push a lot the countries to enlarge their community of users at a national level. So it was seen as a quite weird request at the beginning, but indeed here, for example, I reported two examples. One is for Spain. They are really working a lot with the municipality. If I'm not wrong, 119. We could never arrive alone to this level of engagement at so local level. The other example, if I'm not wrong, is from Poland, and they develop an Instagram page for runners where they provide information to this specific community. Obviously, yes, there are a lot of national products you have seen today in the presentation that was given before. Development of national products based on CAMS data, and this is something obvious in this context. And for us, it's very important the feedback that we got from these national experts on our CAMS product. A lot of use cases were presented in different occasions on energy and health, and this perfectly fit with the, let's say, usual Rubik's Cube that we are used to present to introduce the National Collaboration Program from one side and also the thematic hub. Yesterday we had the Atmosphere User Forum, just to give you an overview of the different elements that were discussed. We use usually the same approach, so we give some presentation from CAMS expert on different topics that we recognize to be of interest because the country asked for this. And then we focus on the specific or the different work packages, given the floor to the countries that are working on it, on them. And then I wanted to underline the user support service that gave yesterday a presentation to introduce the new user forum, some contractual elements presented by Julia, and then also the training, for example, presented by Chris, because these are requests that we get, I don't want to say every day, but every week I can say that is correct. So some final remarks. We want to keep the NCP community active, interested, and engaged with us. This means that it's a continuous work, sharing information with you, with the NCP community, having a contractual review meeting based on work package to stimulate the discussion among the countries and not one-to-one bilateral with the different country. And then attending to your event. So this is for us, this is another important point. Keep listening to their national needs, and when possible, to provide answer, because it's important to collect requirements, it's important to collect needs, but sometimes we have to give a feedback to this quest. So, strong need on training, and yesterday we had Chris presenting the NCP training program, let's say, what we can offer to the NCP. Strong needs on more technical workshop on specific topics, and we are doing this in different way. One was, for example, the session before on dust and air quality, moderated by Julie. Need on more dedicated technical support for specific scientific topic, and again, the presentation of Xiabo on the user forum online, for us it was a kind of response to this request. Reduce administrative burdens, this is something that we have always been asked, and yesterday Julia gave an interesting presentation on all the elements that it's important not given for granted, let's say. Again, I want to put the attention on the national communication. Having this national communication in national language, it was, I think, really a game changer for CAMS service in general, and not only for the NCP. Some next step where we are moving, it's important, as I said before, to keep to give a continuation, because we started quite recently, let's say. So the second phase of this program will be again on a country base. We are going to have one contract for each country, not competitive, modular approach, so the country can select the different work package, and potentially all the countries can be involved. What we wanted to add, also based on some comments that we got from the Commission, but also from some countries, to add a new element on transboundary topic, to give the possibility to the countries to join in a team, let's say, in a consortia, and if they have a topic of common interest, they can join together for projects. I like to close my presentation with these slides, because this is the NCP website with all the different pages from the different countries. And there you can find, let's say, the basic information of, for each country that is participating to our program. So I want to close, this is, let's say, really a small team. Julie are working with me a lot, but we rely a lot on the support of all the other teams. At ECMWF, so the contractor, the communication team, the training team, procurement, but also to whole, we rely on a lot of CAMS experts that are supporting us when specific and very detailed questions come from to the discussion with the country. So with this, I close my presentation. There should be one small thing that is not appearing. Okay. Our goal is, as I said at the beginning, to reach all the 30 countries, but much more important, in my opinion, is really to well collaborate with all of you. So this is really very important for us. And that's it. Thank you.
Thank you, Christina. Are there questions? No questions? All right. Let's move to the next topic, health. Julie Letetre will present us an update on our advancements on the Copernicus Health Hub. So you had already a nice presentation in Valencia last year. It became operational in October, and now we will see what's the next update.
Hello. Yes. Okay, so thank you very much. I hope you're not too much sick of seeing me. I promise it's my last intervention at the GA. After that, you don't hear about me anymore. So we are working on the Copernicus Health Hub. It's not just me, it's plenty of support. As Christina said, we are a small team, but we are quite lucky because a lot of people are contributing to work with us on the different topics we are doing. So. Come on. I knew I would not be the exception. No. Maybe. We can do it. Oh. So I just put that slide again. I know you have probably seen it a lot, but in case someone don't know what is the Copernicus Thematic Hub, so we try to collect all information coming from the different services, different components of Copernicus, put them together and make them accessible to a specific topic or an area. So four have been launched so far. 2 have done by the Marine Service and 2 are done at ECMWF, one by CITRES on energy and one by CAMS on health. We try to bridge more or less on between the community of the topic and you, all the people, all the scientists who are producing nice data, but sometimes that's not always used in this different area. So that is what we try to do. So last year, as Sten mentioned, we had a launch in Valencia, and that was how it looked at that time. But on between, lots have happened. So we had the official launch at the EU Space Week. Carlo Buentempo was there to cut the ribbon, and I promise you he's still sitting on my desk. I was proud of it. Then we had a development of the new website and the catalog. So you can see here a demonstration of what it looks like. We have, following the new guidance, it's not blue anymore, we are in this purple shade. We have introduced more user story, more information about the partner, information about other European projects, more on the catalog, which is still depending on the development. As Laurence has mentioned, the catalog is behind. They're doing a lot in the technical team, so we're doing on function. But we also have the help and support, and I would like to thank Annabelle. Actually, is working very hard, but she said it's nearly operational now. We can put it on, so we will have even more on the help and support. So here is what we have done for helping you to have access to the data. So as I've mentioned, we have a lot of support to work on the hubs, and one of them is having some projects that are relevant at ECMWF. So we have the AD4GD project, and we have the Trigger project, and that actually is a valuable source of information for us because it helps us to bridge to have a real showcase of how our data can be used. We are also participating to many, many events. So Christina said we are happy to go to the country, but we're also happy to go to see the community who are using our data. And you can stay tuned on our page because you can see all the events happening. Not only events when we're making presentation, but also training, a workshop, all can be found on our website. But what is the most important for us is the voice of our users. So yesterday at the NCP, we had already, as Christina mentioned, we had 3 countries has presented what is already happening in their own country, how they're using data, their own data based on CAMS data to go to health or to energy. But it's not enough. We really want to know how you use our data, how that can be useful. Here is for Health is also for energy, but not only. We mentioned this morning agriculture. We have so many sectors where we have an impact, and we would like to know how you, all of you here online, how you're using our data. Thank you for your attention.
Thank you, Julie. Other questions on the Health Hub? No? Then I propose that we, thank you, Julie. Then I propose that we move to the next speaker. Chao Boyang will present us the CAMS user support, a very crucial element in anything what you call operational.
Thank you, Stein. Can you hear me? Yes, good. Okay, I'm going to talk about the user support service for CAMS. So we started with this one owner, the support portal, a few years back. We didn't have everything here. But now, after so many years of, quite several years of development, we now have a controlled support journey to support our users. So you probably haven't thought about this, how far you are from the users. Actually, you are not far from our users. Whenever you develop something, either a new method or adding some new parameters to your existing data sets, they're not far from the users. They're very close, because our users are accessing our data. And they need to understand what it is exactly, because if they don't understand it, then they can't use it. So that's why this support function is quite important to our CAMS service, because people will be able to make use of the data they understand to make more useful products. So starting from the support portal, we developed the knowledge base, which is here in the middle, which the knowledge base is a key component of our support journey because it contains many, many quality controlled documentation. So those documentation are not only generated by ECMWF, it's managed by us, but with a lot of contribution from all of you as a user or as a contractor. So as a user, you ask questions, okay? So those questions may be useful to other users. So that's why, the contribution from the users are very important. But then, on the other hand, as a contractor, when you develop some useful products, it's equally important that you develop a very good documentation for our users. So our team has developed procedures to work with all of you so that we make sure the best quality control of the products documentation here will be generated and will be used by our users. I hope I don't need support to move the slides forward. So I'm going to show this first. So if you have a look at the plot here, so this is how users are using our knowledge base. And you can see that the knowledge base is being used by our users. And you can see the trend is quite clear. Starting from the beginning in 2017, we had we just started, but then over the years, we have over 140,000 clicks per quarter. That's a big achievement, I would say. So now, if I can come back. Yes, this is how the knowledge base looks like. It's not exciting, but I can tell you, it's really useful. I check them quite often, and I'm sure some of you may also check them from time to time, not as often as me. And we are also working on another support channel, which I think is quite interesting. Because over the years, we developed the idea how to integrate the support channels. We have different support channels, but we don't want people to feel, oh, I'm puzzled, I don't know which one to use. So this is why we developed the concept of the duck here, which is a virtual assistant we call, or a chatbot. So the reason why we developed it is because we wanted it to be the entry point or the owner point you need to get help. So why we can achieve this is because all the resources you see here, they are integrated with the chatbot. So they are behind the scene. So when you talk to it, it will search the resources I list here. So that's something we have implemented for another service we run at ECMWF, but we are working on it so that we can do something similar for CAMS. So I'm keeping on talking about we have some good documentation. We want to do a good integrated point so that people will feel easier to use. So I have another example here. This is another example how we care about user experience. So we opened a forum a few years ago, and it's unfortunate that I have never promoted it. So there is a reason behind it. It's because it's not easy to use. I didn't feel good. So that's why we opened a project and we implemented a new forum. So if you go to forum.ecmwf.int, you will see how better it is now, if you used it before. But if you haven't used it, I'm sure you will equally feel it's good. So I'm not going to read all these points here because that's only for your information. But what I really want to say is the forum is a key component we are implementing because we want to make use of the group wisdom or the community wisdom. So you can imagine that as individuals, okay, we know something, we are good at something, but the power of the group it's a lot more powerful. So this is how I encourage you. If you think, okay, I have a group of users that may be interested in something, they have some common interest, then I encourage you to contact us to set up maybe a forum here. I have to say that this is something I will promote starting from now. Yeah? So the support portal, all I want to say is that's the owner channel. We provide one-to-one support. So we dropped the emails because we are quite resource constrained. And the advantage of using the portal is obvious, but what I really want to show you is we are going beyond the tickets. So when you think about support, it's not only answering people's queries. We gather information, we dig information from the queries we receive. So we help with the service evolution. We label the user requirements. We listen to users, and we don't stop there. We try to identify what's new they want, or what we haven't done good enough. And in many, many cases, there are something useful to improve the documentation, as you can imagine. So that's how we improve our knowledge base. And we collect feedback. We make sure that people are satisfied. That's most important. I'm sure you all agree with me. So I'm going to stop my presentation here, and I leave you to read this if you want. You don't have to. Thank you very much.
Thank you, Chavo. Are there questions for Chavo?
can it also, just as an idea, be used to reach out to new users, as it is a challenge? Like, can we promote it now widely via any channel so that people who don't know a lot about the services of CAMS can ask very basic questions there? Or I was wondering about that. Thank you.
Yeah, yes, first I want to thank you for your nice comments. Obviously, you know, this forum is a channel we are trying to promote now. So we have a plan to promote this forum further, because what we really hope to gather is, as I said, we want to gather the group of wisdom. And if you believe you have a certain number of users or a community that can share some common interest, do come to us, and then we will help you set up something before you promote it. So the forum itself, it can be accessed anonymously, so you don't need to have an account. But if you want to post something there, then you will need to register one account at ECMWF. So we can also manage something like the moderator over what we call is a category, or you can think of it as a forum. So we can help with all those. All we are missing is ideas or requirements.
Thank you, Chabo. And I can confirm that we are using it for the CAMS NCP. So that's a sign that we're using it also for user outreach and to collect requirements. So now talking about user requirements, user needs. We move to the last talk. We have again our user uptake guru for CAMS. Thomas, the floor is yours.
Thank you, Stein. So, extending from the Belgian user day of yesterday, I want to introduce my team: Leonor Tarason, Amy Sidworthy, Etienne Way, Anne-Marie Fiera, Diana Derman, from NILO, Admission, CERC, and DLR. And what we do with these user requirements. So we collect by personal contact through other CAMS contractors, through the CAMS service desks, through the user workshops, user requirements. We ingest them into a database. We do some systematic analysis, also assuring full traceability. Where did it come from? And then, of course, after this analysis, decisions need to be taken whether this is feasible. So we interact with the CAMS contractors or ECMWF, whether it's top priority, how much funds or resources it will need. So this is not in our hands. We give it to ECMWF, and in the fundamental cases, ECMWF has to discuss with the EC for the next phase to take those decisions. You see here a graph of the number of user requirements in the database. A user requirement is not a very small technical thing like I want this variable with this horizontal resolution and another one I want it with this length of period. We group all elements that come from a user as one user requirement because this is, we found the most meaningful way of doing it. We see a continuous inflow of user requirements. We started in the beginning with the specification document after the initial user requirements workshop that was held here in Brussels, if I remember correctly, 2012, something like that. Yes, and then we analyze this in a way that we have the 4 partners in the team with different expertise and therefore also different responsibility for different aspects of CAMS services. We do analyze the effort and the potential impact in classes. I will show you how. And this leads us then to this evolution. So since middle of 2016, we kept ingesting those user requirements into the database, and you can see here the number of requirements which are fulfilled. So some were already fulfilled when we started because there was the MAC implementation, and we have a growing number of additional fulfilled requirements. Then we have those in scope, so they are relevant for CAMS services, and we have even faster growth of those. Part of them move into this line here, of course. We have some out of scope, like out of the mandate, for very high resolution, for downstream service, for adding other data like satellite data or meteorological products which are under data policy of other providers and not part of the Copernicus service. And we have also a number of user requirements which are already in the database and which are repetitions, but from a new user or from a new application domain. So this also we keep track of. Yes, these are the classifications. So the class of effort we have from very small correction, some adjustment, few months of implementation work, up to very large research project needed, which is outside CAMS, but still important to document. The potential impact, from little impact, only occasional user asking, up to high impact, either from a power organization like a European DG, for example, or EA, or a large number of users. And then we also identify some actions, further discussion needed, what can be done with the user requirement. Yes, and now I'm talking about some of the last 1 to 2 years, grouped in those 4 areas of expertise. So the general and global user requirements. We receive, please go back. Yes. We receive quite a number of requirements for the website, but also for the data store capabilities. We had requirements for additional coverage, the Canary Islands in the regional service, the coverage of the specific dust sources in Iceland. We had this in other talks today. A number of requirements for the next global reanalysis are under evaluation to help determine improvements. Also some gaps or barriers have been identified from these requirements and also the broader feedback in the user workshops. So involving intermediaries who have to support stakeholders, authorities, but also have to make money. This is still not easy, and it's still a challenge to bridge the last mile and also have a sustainable business model. Orchestration of the support of national core users by companies is difficult. The user uptake mandates from CAMS and USPA are also not always easy to explain. I think there can be further evolution on this. Downscaling is a frequently required challenging topic where support is needed, and the NCP is having this activity. The MOS is an approach in this direction. Agriculture seems there is a gap between the maturity of the CAMS products, also the resolution, and this community. On policy, there was a growing number of requirements for training and documentation, and activities have been presented partly today in follow-up of this. Then there is a request for data availability, like for the interim assessment report, not only the report, but also the numerical data to be downloaded. Then there are development requests to increase the number of components in PM speciation details. Then we had this topic of subtracting natural sources, so the expectation that CAMS can help here is very high. Source apportionment product, further detail. Satellite-based emissions, so the CO2 MVS is a co-design opportunity here because there are national communities working in this regard. Future long-term scenarios, not only forecast for the next couple of days in the scenario tools. Yes, and downscaling again as a topic. Then the downstream sector for air quality information. Quite a number of recent requirements have already been set up with the new, satisfied with the new air quality website, European air quality website of CAMS. for example, those EPS grams for many more cities, or plots which are really optimized. We have this continued request for higher resolution, in particular for this application, and we have also for this application domain requests to even further evolve the atmosphere data store, for example, with all the emission data sets, functionality to access specific parts of the products, or to get more maps available on the CAMS website. And finally, solar energy. There was the main repeated requirement that the limitation on the number of requests is too strict for many applications, not for this case that we had for Belgium, because it's only covering the area of Belgium, but for larger area applications, this is a repeated request. Then near real-time availability of solar data, and extending the coverage beyond the Meteosat second generation, which is already partly answered with adding Himawari. Yes, and my last slide, some concluding reflections. So we had a session today with this topic of dust exceedances, so this is taking a lot of interest. Then I think we can claim that there is a good cross-benefit between the NCP and the CAMS user intelligence activity. Maybe it needs to be readjusted now that the NCP is in full flavor, or to be optimized for the next phase. But the opportunity that our activity with one user workshop and one taking stock in the country can be followed up with the NCP, or other way around, this creates a line of activity, and that's very good. And we saw examples, for example, in Spain, that our workshop created a capacity building activity in the country when there was another workshop where the actors in the country said we need a better link between the national and the regional level, and here we have to do something, and they did it. Yes, policy tools are used very differently. Some just use them on their mobile to get fast information. Where does a pollution episode come from when a minister calls and wants an explanation? It's not what they are exactly meant for, but this is also interesting to learn. I said this co-design opportunity for the CO2 MVS. There are other players in the field, like Google, providing also some data related to our field. And there are issues of visibility and branding for subcontractors, but there's also issues of confusing users with data access. So we had this topic also, different portals for Copernicus, data of different flavor in the user workshop for Belgium yesterday. Yes, for the future, maybe training should be even more combined with user workshops. Guy, you raised this point of reaching out to unknown users. This is a remaining challenge. We once even brought in a company who works with startups to benefit from their networks, but it proved to be difficult. It didn't have that success that we expected. So more ideas are welcome. Yes, and this is, I think, the largest challenge to find the unknown users. So any idea that any of you may have, please let me know. And with this, I close, and thank you.
All right, Thomas, thank you. So we all have a task to find Wally in the group. With this, I want to close the session, unless there is still a question from your side for Thomas. No? I think we're all tired and we all are longing for a drink. So I would say take your time to wrap up here and then slowly go to the museum so you can enjoy it. The weather is still nice, I think. So thank you for your attention, and tomorrow we continue.